Hello, hello. And this is it. We're going to make more progress on Cast today. There was only 4 Cast streams in February. Huh? Well, there were a bunch in January, though. It seems. So all good. Alright, what are we going to work on today? What are we going to work on today? Hello, Nerdful. All right, I think what I want to work on is like making LSP fast right? So right now we like currently everything is recompiled from scratch on every change. Let's fix that. All right. But the reason why everything is recompiled from scratch on every change is because you're actually now playing your own game for fun. Unfortunately, still competing with yourself. Close to light. Nerds is currently playing Close to Collapse 666. All right, I was thinking about it, but no, we want to work on Cast. We don't want to be playing games, right? Right. Next Squidward stream playing Costlized Imagine. Yeah. So here's the thing, right? The currently the LSP is doing everything from scratch, right? We don't store everything in the file system at all currently. Chat is off. Whatever. Do we need it? That's fine. Currently, everything is happening from scratch. But right now, it's like basically I'm changing this file, for example, test KS, right? This is one of the examples. But we are going to recompile the entire workspace, so all of the examples, all the standard library, everything is going to be checked from scratch when we change a single thing. It seems like the LSP does not report the time it took to process the workspace though. Let's take a look here at processing. Maybe I changed the log on accident. Yeah, recalculating LSP stuff. Timed. This is log info. I'm supposed to have it in this output, right? Time. Why do I not have it? Oh, because recalculate. Yeah, because this is the initial calculation, right? Okay. So here's the thing. If I go to test KS, right? If I want to change something here, right? Like for example, I want to like do a random symbol here, right? And I think it's recalculated. So the recalculating this stuff took 6 seconds actually. 6 seconds. What is this syntax? This is syntax for initializing a map. Supposedly, it is not implemented yet. We were just thinking about it the other day. Right. So it seems like recalculating LSP stuff takes 6 seconds, which is a long time, of course, to wait for the syntax highlighting, for example. Right? But we're trying to calculate, to like process all of the cast code. So how much cast code is here? How much are we processing? We're processing 2.4 thousand cast lines. Or like 2,000 basically, right? If we don't count the comments and blanks. Which means that 2,000 divided by 6 is like 350 lines a second. Not very fast, I suppose. Can we make it faster? Let's try to do this also. Cast, compile, examples. Right? Like, if I compile just a single example, it is very fast. Relatively fast. Maybe not very fast. So it's not 6 seconds, because I have a lot of examples or whatever. Right? So what we want to do is, if I change one example, I don't want to recompile all of the examples. If I change the standard library, though, obviously all of the examples need to be recalculated. But how do we do this? Like, if... So right now, the way it works, if I need to have the information from the LSP, we're waiting for the entire workspace to be processed to the latest version of all the files, right? Which means that, like, if I make a change and during that change, the processing was happening, we don't stop the processing. So we need to wait for one processing to happen. And then we need to start new processing with the new state of the files. What was I saying? Yeah, we wait for the processing to finish, and then I start the new processing with a new state of the files, which means that it potentially takes twice as long. And like if it takes 5 seconds to recompile, then it would be like 10 seconds potentially. of us waiting after the change in this thing. So yeah, there's like multiple things to do here. There's multiple things to do. Also, I think that so let's say that over here, right, we have the standard library, right? We have standard library, and then we have like these examples. So the examples, they depend on the standard library. Right now, we don't have like big dependency graph, basically just like this. At least in this repository, right? But let's say that the standard library was also depending on like some module, and this module depended on this, like something like that, right? It could be our dependency graph, or in the examples we could have some dependencies, whatever, right? So we have this graph like this, and let's say that. So what we want is when we change a node, right? Like if I change this thing, then everything that depends on it needs to be recalculated, but the other things should not, right? That's the idea here. So the smallest thing that we are going to be recalculating, I believe, is going to be the files, for now at least. There are ways to make the compiler more incremental, I suppose, but we're not going to think about that. We're just going to say that we have the smallest unit of compilation, which is, I guess it's not exactly a file, it's more like a crate in Rust, right? Which is potentially multiple files. But we do want to know the dependencies of all the things. And when it changes, we need to recalculate it. There is another issue, though, with not recalculating the things, because we actually had it at some point, right? Let me take a look at my LSP here, right? So we say update file, right? What we're doing is we're removing this file from the import cache, which is like the compilation cache, I guess. That's the only one that we have. It's the import cache. But I think we should rename it to compilation cache, and import is just like one of the ways to do it, right? So every file needs to is potentially going through multiple things. First, we parse the file, then we compile it, and then we also potentially evaluate it. So when I'm importing a library, we also evaluate it, but the examples, they still can be compiled, I suppose. So that's that. There's that, right? But the problem is, if I have something in the import cache right now, I believe right now what we do is, yeah, there we go. We have a to do here even, right? So literally when I'm processing the workspace, I am saying that we initialize the import cache from scratch every time. So we clear the cache completely. But what we should do instead, we should actually remove this. We should not do that at all. And we just go over the workspace roots, and we just process every file in the root. And if the file has not changed, actually I should not process it either. What does it mean to process a file? It's just compiling it, parsing and compiling, yeah. So let's see. So first of all, we need to have like the dependency graph, invalidate dependence when invalidate dependence on change, I guess. In general, that's what we do. That's what we need to do. The other thing is don't wait for all processing, only for needed ones, right? So for example, if I only want for a file is to do syntax highlighting, I don't need to wait for the file to be compiled, right? That's one of the example. Also, if I want to have the LSP support for a specific file, I don't need to wait for all of the other files that are depending on it to be processed too, right? So if I'm working on the standard library, I don't need to wait for all of the examples to compile. I only care about the standard library, right? Yeah. Another thing to do is like cached results must be immutable, right? So the thing is, in the when I compile a library like standard library, and then I try to use the standard library in another place. Here's the test, for example, right? Let's just comment everything here. Let's just say stdio print 123. Like, right? Like, this is obviously wrong because the printing requires the string argument and not an integer, right? This says that number literally is inferred in string, which is fine, right? If I say that this is an int 32 though, for example, then it's going to give me the other error message. So the error message here is now that string is not int 32. Could be better, but it's okay. But the issue is, actually this still says string into unit, which is weird. What if I say stdio print hello now? This still works. Do 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 do. I thought this is supposed to not work. Maybe I misremember how things are working here, but yeah, because the inference, the type inference right now, the way it works is it's literally mutating the inference variables, right? So by using a library, I am mutating the types in there, right? Because we are advancing the inference, supposedly, right? Which should not happen if we are caching the things, right? So if we want to cache, it must be immutable, which also means that the libraries cannot have unresolved variables, right? So we on one hand are able to do the inference even across the files, but it doesn't work well with caching, I suppose, right? So for that reason, we had the thing called inference completion, which is a process where we ensure that all the inference is completed, so all of the types are inferred, and there is no not inferred types, right? So when I finish compiling a thing, I should make sure that everything is inferred, right? And then we can cache it. Otherwise, caching the not inferred things shouldn't be possible, probably, right? The reason I thought this doesn't work is because I believe when I'm doing the inference, let's take a look. Inference here. When I'm unifying, right, unite type shape, this thing. So when I'm saying that I have type A and I have type B, and if I am failing, which means that they are not equal to each other, right? Like if the type inference fails, then basically we still unify the types, but now they are all the error types, right? Because the LSP should not stop on errors, and we should continue compiling somehow. So we say that these types are now the error types, which I thought should lead to the fact that stdio print would be inferred after this error to be having the type error into unit. But that is not happening here. How about I change the workspace to... Let's do this. Oh, we have playground test KS. There you go. Let's comment this out. So this is not going to be needed at all. So this playground, yeah. This is it. Okay. Let's see, since I have commented those other examples, this is now actually responding. The LSP is responding a lot faster. Feels like I can use it. So yeah, we want this... Or, I mean, it should be even faster because it still is compiling the standard library from scratch. I'm just not doing the other examples. But it feels so much nicer. So stdio print is string into unit. Yeah. So why does this? Why is this not the thing? Maybe if I do this, let f is string into unit is stdio print, right? Like I can do this. This should work. But if I say that f is int32 into this is not going to work. So what's the type of f now? Int32 to unit. Why? Let's do mut. And let's do again. F is stdio print. Let's try to break it. Like, why is it not breaking? I'm not understanding my own algorithm anymore. Oh, look at this. Yeah. Look at this. And now I'm harboring the stdio print, and the type of it is int32 into unit. It's a little bit weird, right? And this is wrong. So, like, obviously this is not the type of the standard. So over here we have the error, and over here it's no longer the error, because, like, you know. So anything after the first error is not to be trusted. But I think the way I'm fixing it, so let's fix that first, I think, right? Which is fix inference after error, I guess, must be done. So here you go. The first line over here, this is wrong, I think, right? So if we have an error and something, and we have something and error, then the unification of those is this something, right? So the error is unifying with the other things, but that is wrong. And also, I think the fact that we are converting the type into error is also wrong. So I need to change something about my algorithm here. So the we just use the unification for the inference. So I have inference variables, right? So they start by being unknown, and then we can sometimes say that they are equal to each other, right? And when they are equal to each other, we basically check that they are actually equal. And if not, then I am still saying that they are equal, but now they are equal to error. That's what we are doing. But what we should do instead, if we are trying to make them equal, and this operation fails, then I should not treat these types as equal, I guess. Right? So if the inference fails, then it should not. But I'm not sure if this is actually like easily doable in the way my language works. It's not that easy. It's easy in some cases, but not in all. So here's the overall inference algorithm. We basically say unite. Unite, right? So we're using the DSU data structure here, where we basically, if we have like multiple variables and they like are equal to each other, we store the entire connected component in one of these variables basically, and all of these are like pointing towards this main variable. It doesn't matter though, really. I guess this doesn't really matter here. But here's the issue. I'm actually doing the unification twice because I'm performing the unification twice here. Because this data type, because the types can be like recursive, and we need to treat the type, and we like while doing the unification recursively, we might see the same pair again, right? And if we see it again, then I don't need to like to do the same to do the same thing, right? I don't need to do the same thing. Yes, I do not. Which is So what we're doing over here is we are saying that when I'm unifying variables a and b, I'm saying immediately that they are equal, and they are equal to a, right? That's what I'm doing before performing the unification. I already immediately set them to equal. Then I'm doing the unification. And then during that unification, we potentially were uniting this with something else. We need to unite it again. This is a little bit weird. I feel like it might also be wrong here, what I'm doing. I don't think I can. So what I want to happen is I want to not even make these variables equal, right? But I don't even know if this is going to fail or not, because I'm making it equal before writing the unification. So like this is the operation that is supposed to fail, but I'm making the variables equal before because of the recursion. But I feel like what we need to do instead is we need to we need to make, so like this over here, this unification of the things should be temporary, right? And we should be able to undo the unification then, right? Yeah, we should be able to undo it. Let me take a look at the unite data. This is just on unite, data on unite, db on unite, data is this, on unite is that, unite data, unite inferred. Bum 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 bum. Like it also further complicates by the fact that the unification is not an like instant process, and it's an async thing. It's an async task which might not finish immediately, but only after some time. Well, not exactly, but like it might spawn the other async processes, right? How much code do I have again? What if we rewrite everything from scratch, guys? 22,000 lines of code. Do you think I should be rewriting it from scratch though? Din, 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 din. Probably not. You don't know better than me. Yeah. It's just like at this point, like doing the smallest changes requires so much time, right? Like some of these things they should have been like maybe done from the beginning. Otherwise, it's like painful. But how do I like look into the future and know about all of the things, right? Like in the previous rewrite, we did not have the LSP at all, right? So and adding the LSP there, I think, would be really difficult. I think, but I'm not sure. The D2 GM starting with this weekend. Well, the next one, yeah. It's exactly in 1 week, right? To March 6th. Is there no countdown? No, I guess 6th of the March. Wait, theme voting. Did I not vote already? Or was that like the theme elimination and now it's the voting? Let's vote again. So drift. Oh, there you go. Now I can start. Oh, it's in the final. Yeah, we can like start drift. We can have 2 stars, so we can have like 2 themes that we really like. And we can have the themes that we do not like. Well, we definitely don't like blends. We definitely don't like steps or combination or rainy day or fractured or exploration or release or unconventional combat or deja vu or point of view or abyss or running from danger, forbidden, and balls. We only like drift, I think. What about rewriting the LSP? The LSP is integrated into the language. The LSP specific code is pretty small, I think. So I mean, this is like a fundamental problem of the inference, the way it is done here. Like, you know what would help? If I had like a simple language to play around with and not cast, like a mini cast, you know, just to play around with some ideas, right? But like, then we want like something to be like, I want to like strip this language of a bunch of features. No, that minicast was like a different thing. It's just it was a different proof of concept there. Of splitting the project into like modules properly. Like, why is this here, for example? Why do we unite twice? right? Well, like I said, it's because we potentially are going to unite recursively, and this should not happen. So we should treat the values as equal when we are uniting recursively. Boom. But maybe like instead of like doing this, instead of mutating immediately, we're going to only mutate once the unification is successful. And over here, we're going to treat them as equal in some other way, basically. That's the idea. It's either that or undoing the unification, but I guess it's better to just do the immutable thing. Actually, how do you like write this inference algorithm in a language like Haskell where everything is immutable? I'm wondering about that. Do you think we should try writing a simple language in Haskell to like understand how it's done? Maybe not in Haskell. Like it doesn't have to be in Haskell. I can write it in OCaml still, just like in an immutable way. Do the inference from scratch. We can keep the parser, I guess. I mean, that is if we want to distract ourselves and not to work on the actual thing. It would help, though. It would help. All right, so what we need is for the unification to have the context. Like similar to when I'm printing the types, I have this thing called recurse cache, and we do not like print the thing if we have printed it already. We instead say that like it's a recursive thing, right? And similarly to that, we are going to instead of that, we are going to... So temp data is just data A, yeah. Root A, root B is RNG, yeah. Like, I'm thinking of this thing where find root. This thing can be overridden in the current cached. Unless you're using effects for error handling instead of some monadic result type. Has this slowdown been significant at all? Maybe, I don't know. Like I'm mostly working with the native OCaml, right? The JS of OCaml is only done to do the playground. So maybe like the playground is actually really slow because of that. I don't know. Right, like let's see what is the response time here on the JavaScript side. If it's even working, maybe I just broke it altogether. We just uncaught exception object. Maybe it's not working at all anymore. Can I run? No. There was 30-50% slowdown by just enabling effects for just OCaml. Yeah. I mean, if it's like twice as slow, it should still be good enough. But yeah, I'm breaking my my online playground all the time, I suppose. It's not working right now. I think on the native backend, it is pretty fast, right? JS over camel. Cast. JS. I do the effects double translation, whatever this means. I don't remember. Oh my god, the light theme. No. Effect handlers are supported with the CPS and double translation. So like there is two ways to do the effects in the JavaScript. CPS and double translation. Actually, you know what? I'm like thinking about this. The way I am transpiling my cast code is I am doing the I'm basically transpiling into async JavaScript right now, which is basically the same as the CPS. I tried the like manual CPS versus async JavaScript. They perform almost the same. CPS is actually a little faster than async in JS, but ideally we don't want the code that does not need to capture the continuation to be written in CPS or async style at all. So what does the double translation even mean? So it means that you translate the function twice, first in the CPS style and then in the regular style. But how do you decide which one to call is the question. I would like to read about this a little bit. How do they do it in OCaml? JS of OCaml, double translation. Keep both direct and CPS version. Choose at runtime. There we go. It's like choose at runtime. See effect handler for details. Double translation mode. An alternative CPS transform is provided with effect double translation. It keeps the direct style version of the transform functions in addition to the CPS version. The choice of running the CPS version is delayed to runtime. I believe this is, yeah, because CPS style is usually slower. This can avoid performance degradations. You can also ensure that some code runs in direct styles by using the JS effect assume no perform. Right. Yeah, but how do you choose it at runtime? That's the question. That's because like that's what I want to do for my own language, I guess. I want to do the double translation. And how do we choose one to use? Is it documented further, the implementation? In JS, OCaml, they can do double translation for effectful code and choose which version to use at runtime. How? So So there is one version assuming the continuation support and one version assuming the direct style, right? So then we choose at runtime which one to execute, right? So how do we choose it? Normal calls, fastest, no effect handling, continuation aware, can capture stack. Makes sense. The runtime instruction. What generation is just file share a common runtime layer. The runtime blah 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 blah. In addition, if double translation is enabled, some functions are defined in two versions, and the generated program switches to the CPS version when entering the first effect handler and back to direct style when exiting it. But that's not enough, right? That's not exactly correct. Like, that's not enough to do the optimized code, because, like, let's say that the code that I'm writing, right? Like, so if we only, like, basically, what this means is we have any effect handler in our scope, then the code is running in the CPS style. And this is different from whether there is any effects performed from within the code, you know? So even if you have the effect handler present, it does not mean that all of the code inside should be aware of that effect handler, right? So let's say that you have code like this, right? Let effect plus equal like test. Right, so we just do try with effect test, okay. Then we just effect deep continue, okay. Like this, right? So this means that we're capturing the continuation, and like I call the function f here, whatever, where f is a function that is actually performing the test, right? Like this. So this function actually needs, because it's performing the effect, this one needs to run in the CPS style, right? Because we need to capture the continuation here. But let's say that this function not only performs this, but it also, like, I don't know, calculates 2 plus 2, right? Which is using like function add 2 and 2, right? So we are calling the other function add, ab is a plus b, right? So this function over here, this function does not need to do anything effectful. We do not need to capture the continuation here, because there is no effects performed here. But according to this thing that you copied from the docs, the effect handler is still present here, which means that this function would also be ran in continuation passing style, adding more overhead, which is bad, right? But you cannot fix this in OCaml, because in OCaml the effect system, like, is not present in the type system, so you don't know if this is going to perform the effect or not, unless the runtime can also somehow, like, infer this information based on the compiled code. But yeah, you're saying that the generated program switches to CPS when entering the effect handler, which means that this over here, in this try, everything over here is going to be in the CPS style, including the adding more overhead than needed. That's what I'm saying. So yeah, if my entire, like, program is wrapped in the effect handler, this means that my entire program is running in CPS style. That's bad. So you say if effects enable, run effectual versions, and also run fun version. This is basically the strategy for the entire compiled programs. Because CPS everywhere is slower. So like this only works if you don't like have global effects, I guess, over the entire program, which we do. So is it true that CPS is enabled if there is an effect handler installed, even if current function is not going to perform any effects? No, not necessarily. Does this function actually need to be CPS transformed? Is an effect handler installed somewhere up the stack? These are not the same. Yeah. If there is a handler on the stack, then everything below must be CPS. That would mean every function call, every helper gets continuation. Yeah. That's a disaster. What actually happens in the serious compilers, but is the JS of a camel serious? So we try to distinguish the code that may perform and the code that cannot possibly perform. This is a static analysis problem. If the function doesn't perform, in fact, and doesn't call anything that might perform and doesn't capture the continuation, then it can stay in direct style if there is a handler somewhere above, right? But handler alone, yeah, that makes sense. So is JS of a camel actually detecting whether functions may perform or never perform effects? Because OCaml itself does not do that. So JS of OCaml is not doing deep effect analysis. This job belongs to the OCaml compiler, but does the OCaml compiler do that? The component. So OCaml knows if function may suspend. Is that true? For sure. OCaml knows some things, it does not know everything. In OCaml, performance is explicit, effect handlers are explicit, the compiler rewrites effective code into continuation of where form. We don't track the effects in the way Koka or F might. This is too much. Text. Alright, whatever. That's not what I'm looking into right now anyway, right? Would be good to know exactly. But I mean, I like if OCaml, the compiler, is doing this analysis, why don't we have it in the type annotations then? They do plan to add the OCaml, like OCaml effect typing or something. Safely typing algebraic effect. OCaml with typed algebraic effect. Hold on, what is this overview? Is this like the actual fork of the OCaml from 10 years ago with typed effects? Is there going to be typed effects in OCaml one day? If they go, I mean, yeah. Why they didn't start with type effects? Because they wanted algebraic effects in production. Compatibility, the runtime first. It's just like, I mean, I'm doing the same, right? Like right now I have the untyped thing. And I want to add the typing later. But because of that, I cannot, I believe that it's because of that I cannot compile my code effectively. Because in order to compile it effectively, we need to infer, and inferring requires the typing to be there. Basically. Alright, anyway. Yeah, I'm trying to make my LSP faster, that's all. But yeah, the issue is the way my inference works, right? That's like the fundamental issue right now. So we are doing unification. And I'm doing unification in a mutable way. And I make the two inference variables, I unify them, right? I make them the same before actually unifying the value of the inference variable. And if that unification is failing, then what happens is that both inference variables become equal to the error. Which is wrong. Kind of, right? We just should not do anything. But how? How? So I think inference base, I guess, is what I want to go again. So do we have the error here? Error. Right, so what is this, by the way? Why am I handling the error and just like basically rethrowing the error, returning A? Oh, so like if we could not. Oh, this actually means that if I could not unify, then I just return A. But this doesn't matter. It doesn't matter because I have unified them already here before this effect had a chance to be like performed anyway. I guess this is the old code before I was unifying twice. So like I'm tempted to do the context of the unification, which would which would be able to do the like all of the inference that is being performed temporarily, and only after the successful finished unification we apply the changes. Is the idea, right? I think that would make sense. I think that makes sense. So let's see. So the idea is something like this, right? We are operating on the inference variables, which just have the state, right? Just the mutable variables. And instead of mutating the state directly, we can have the context. Which would be, so I need the IDs of the variables then here, right? ID. Yeah, I need the IDs of the variables in this case. I forgot how to write a camel semicolon between the fields. So the context would be the map from the ID to the state instead. Like I think maybe, like if I was to rewrite from scratch, I would actually try to write the inference in an immutable way. That would probably help a lot. Yeah. Should I write my inference algorithm in an immutable or immutable way? Mutable core immutable interface. Unification returns new environments. Yeah, like what we're doing when we're doing the unification, we are mutating the thing, right? But we should not. So it should be like a result which changes my current environment, right? Which would yeah, no destructive union find. But it is destructive right now. Everything is structurally shared. Like, I do not have the env currently. It makes sense. At the same time, though, like, it kind of makes sense on one hand. On the other hand, we are doing the async processes, and multiple things can mutate the thing. How do you even do that then? So we are actually using immutable type variables. We do unified with path compression, yes. Instead of returning substitution, you mutate, yeah. Unification becomes side effectful. It's simpler to make fast. A camel using the mutable union find. Dun, 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 dun. Fully persistent substitution passing, you will regret it. Okay. What is this stream title? I don't know, just some random title. What's wrong with it? Are you mad there is no C++ in the title? I heard you like C++. You wrote a small bit of C++ recently and you really liked it? Yeah, but you... you also write C and you liked it? And, yeah. I don't know. Yeah, you love C. You love C, you love C++. I don't know. It's kind of like a weird thing. It's like, you know, it's like I like playing Zomboid, for example, right? So, I mean, I also like suffering. It's just a different kind of suffering. Hello, Raymarch. Yeah, you're writing Rust more than both languages combined. Yeah. So the reason we are doing the mutating version of the inference is because it's fast, I guess, right? Mutation is how you make the code fast. But now we want to also not mutate, so the code becomes more complex. It's kind of funny how bad C++ is. I don't know, what's bad about C++, Raymarch? Let's hear it. What actually is bad? Are you just hating? Maybe you're just a hater? Maybe I am also just a hater? Is there any actually valid reason? Like, what's the problem? You don't actually want to rent? You can do C++ there, I hate it. Hello, Hans Sohai. Alright. Yeah, I also don't want to rent, but yeah. I don't use C++ that much, so usually I rent about OCaml, because that's what we write most of the time when working on Cast. We can rent about Rust too, and am I using any other languages? Not really. But like, when we talked about this before, the biggest complaint about C++ is that it is bloated. And like, personally, I don't get this argument actually. Like, I don't like C++ because of how easy it is to write a bug there. That's like my only problem. I don't have a problem with C++ being bloated. I'm making a bloated language. I like bloat. Bloat is the way, I think. The move semantics, yeah, I think the move semantics indeed is a little bit wrong in C++. That's better in Rust, I think. But like, what's the like? There certainly is a reason, right? Is there? Can we read about the how did they come up with this decision that when you move, you need to leave an object in a like the problem is that bloat is the way. Yeah, could backwards compatibility make the bloat? I mean, yeah, it's mostly because of the backward. I mean, it is because of most of backward compatibility, but at the same time, like, what would you remove from C++? Is the question, right? Which I asked before, and I don't think that there is anything I would remove. There are things that I would change in C++, but not remove, right? Like for example, move semantics. We don't want to remove it. We want to make it better, right? Dangling pointers, uninitialized variables, and now zombies. Is that the things that you would remove in C++? But like uninitialized variables is important. I believe that uninitialized data is important to be able to, like, for performance, right? No, those are the things that we worry about. I mean, yeah. There are things that you need to worry about, but like the reason they are there in C++ is valid reasons, I think. It's just like that. That's why I don't use C++, right? Because I don't want to worry about things. I want the language to worry about those things for me, which is why I like Rust more. All right, are we getting anything done today? The idea here is that I want to fix the inference after error, right? This is the thing that I'm working on. Because yeah, right now the inference is bad. If there are errors, the error resilience is, I mean, important for the LSP, but it's done in a wrong way where the types get wrong after the first error. C++ is great if you're a happy path coder or protecting the project and leaving. Yeah, I guess. Which is why I think it's good for things like competitive programming, for example, where you just write the code once and then you never come back to it. Yeah. But most of the code is not that way, right? Most of the code needs to be maintained, at least for a little bit. Right. So what we want to do, once again, we're doing the unification inference, and the way it works is that we have inference variables, and we say this thing must be equal to this thing. And the way it works right now, we may basically unify them into a single variable immediately, and then like try to see if that works. And if it doesn't work, then we assign this to error. Which is wrong, because it means that if it cannot be unified, then the previously inferred type becomes an error. So over here, we're trying to assign the stdio print to a variable which is not taking a string as an argument, but an integer. And what this results into what this results in. Maybe we can have a simpler example. Let's say let x in 32 is 0, let y in 64 is x. So if we do this, I know it's weird. So right now it says that x is of type int64, even though we have the type annotation here that it's int32, right? I think we need to still like keep these separate things and just not unify them. That's what I'm trying to do here. I want to write software that runs for years without a bug. Is that too much to ask? Years aren't gonna change if your already built software is buggy or not. All right. Well, I don't know how to comment on that. What I know is that my thing is buggy here, and I'm not working on it. People are doing that with COBOL. Is COBOL a good language? I never tried COBOL. English-like computer programming language? All right, so what we want to do once again is we want to not mutate the state immediately, but instead of doing that, we want to have temporary substitutions, and then once the unification has successfully resolved, we are going to apply the changes, right? Right now, for every inference variable, we store these things. We store the actual inferred value, which is optional. We store the spans, which is like all of the locations in code where this variable is present. I feel like that's unnecessary. I mean, this is just for debugging purposes, I suppose. And I have like these mutable things. Scope, once inferred, setup default, once inferred on unite. You just want a nice assembly wrapper language. Why do you need to wrap assembly? Well, I mean, if you say that you want a nice assembly wrapper, does it mean that most of the code that you write resembles assembly? Our CEO was talking about this company that has been using Delphi for important software for decades. Of course, this is a company in 2026. So the context was that they wanted to train AI on Delphi, so AI can maintain their code base. So I think the context here would be the actual states of the variables, right? This is what I guess we call the env. They call it the env, the inference environment, like the type environment, I guess, right? Where for every variable we know its state or whatever. we call it context here. So states of the variables, is going to be ID map from ID into the variable state, I guess, right? Var state a scope. So when I create the new inference variable, I just have the ID is ID gen. ID gen. Okay. So now instead of getting the state from the field of this thing, we're going to get it from the context, if it's present there, or from the actual state, right? So like the context gives us the temporary overrides of the variable states, I think, is the idea here, right? So when I say find root var, we don't check the var state. This is doing the compression of the paths. 2. Or maybe like what we want is not the states, but like, let's say overrides. It's just going to be ID map for a variable, right? So we literally have a new variable for every variable. So when I say find root var, we just say that var is with get var get var get like current var something. Get current var is so at first I need to get the context somehow, and then we say context overrides ID find opt var ID, and then we match this. If we cannot find it, then we just return the variable state. We just return the variable, and if it is some override overridden, then we return this overridden variable. I think that's the idea here. So how do we get the context? We just do it by doing the effect. Get context, I guess. Which gets the context effect. Does this work? Can I do the underscore here? Can I just say over here effect perform get context? Right. So find root var. That's all, yeah. And yeah. And then we want to have like the way to do like with temporary with temporary context, I guess. It's going to be a thing which takes a function unit into a or return a. I guess so. We are just going to wrap some certain things with this. So it's going to be function f into like try call function f with effect get context k into effect continue k context. So we need to initialize the context here. Does that work? Seems like it does, right? So if this function actually returns successfully, though, then it means that all of these overrides needs to be performed, right? Can I like see if there's any other effect? I want to also make sure that, like, because we are going to mutate it later, I want to make sure that nothing else mutates it concurrently, right? Because this is going to now assume that we are basically locking kind of the global context. Maybe I just literally do the lock actually. Well, not the lock, but because like I'm not even multi-threaded, right? I should like just check. It's more like the ref cell, right? We should see if no one else is mutably borrowing. Even though we are not mutating this state of the inference, we are assuming that no one else is mutating them. Because we're not doing it in place anymore, right? Something like that. Just have for now to do check if check that no one else is mutating. I mean, let's just do it immediately. Actually. How do I do it immediately though? We just have the variable here, right? Mutating is ref false. So over here we just say that if mutating, then fail. Already mutating. Mutating is true. So we're doing this trying, and then we say mutating is false. Well, I guess we do like we do like try finally. No, there is no finally, right? There is just like function protect. Finally. Function mutating is false. You always make me want to have some orange juice soda. I don't have it that often. Do I? Context is this. So then we try to do this function. So like, yeah, after this function is successfully done without any errors, in this case we want to actually implement these overrides into the actual thing. So I want to also keep the original ones, right? We also want to keep the original ones here. All right, original. A scope override type a scope override is a scope var original as this, right? So we just go over this map over all the values, and we just from the overridden get the state and assign it to the original if the function returns successfully. So here, right, we just say context overrides id map iterate. We don't care about id, but I do want to have the override and original here. The type has type unit which is less general. Let result be this in result. There we go. So this original and override, right? We just say that original state is equal to override state. Now right, and I don't like when I say get current var, right, it should always be in the current context. So if the variable is not present here, if the variable is not present here, then I should still like create it, right? So say id map add to the context overrides. We need to add a variable id to this thing. So we're going to add the override, and original is var. Equals type AB override ID map. Oh yeah, because it's a map, we need to like mutate it. So overrides, this must be mutable, I guess. And we say that context overrides is this. There we go. So context, yeah, the typing here is a little bit weird. The typing here is a little bit weird. I have the variables with like different things. Can I be polymorphic over the type here? Because I only care about like this thing. Like I don't want the context to be polymorphic. I want it to be like this somehow. But the override is overriding this thing. So this should be a map of the overrides of the variables. Okay, we are just going to do the unsafe OCaml object T. There we go. It's a little bit unsafe, but it's fine, right? So this over here is object, you know. Right, so I'm going to say that this is override is object object override. Like we are guaranteeing that it's the correct type because the ID is correct. Oh, but what's the type here? This type is unknown because the override is also polymorphic. So like, what's the type here? So A here is the what the inference variable is inferring to. So we have inference for types or inference for values or for other things. So this is what we infer. And the scope is another thing. Bum 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 bum. I mean, I kind of don't care about the type here even, right? Maybe we just say that override is two objects. Like, this is so wrong. This is so wrong. This is so wrong. So overrides is going to be like the overrides here, after all, not the objects. And we're going to cast here. Oh, but I cannot even get, like, it doesn't matter. Right? Like, I need to, like, if this is the variable. I mean, maybe we just say that A and scope is something. Like, we literally, we can lie to the type system here. We can say that it's just unit and unit here, right? And it doesn't matter, right? We are lying about the type of override, but it is perfectly safe. So when I get the current variable, the safety is ensured by the fact that these are stored by the ID, and this override has the same type here. So we say object dot wrapper of this thing. So this is the actual override, right? I'm just should I pick our C or C++ for Raylib? I don't know. What are you trying to do? Would you like more? You can do any language. You can do Raylib and Zig or Rust or I don't know. Pick Ada like sorting. Sorting is doing the Raylib in every language, right? Did he manage to do the Raylib in Lean? I saw he was doing the Lean the other day, and then John Blow was doing Lean the other day too. All right, so this code is probably wrong. Let's just try running it. Cast compile examples SQL. So we're going to have the exception here that the effect is unhandled. Unhandled get context, right? So we need to make sure that the that all of the inference is happening through the with temp context, right? So over here, for example, right, where am I calling the thing? Compile, raise exception. Compile expression, compiler eval, compiler default, cast handle effects. When the exception is being re-raised, I don't know the original like place where it was like what is this compile? So the exception handled while doing this thing. Yeah. What's Ada? It's a programming language. Am I targeting LLVM? Not yet, no. The current... I think I have it... I think I have like something... Here's the compilation target plan. We start with the interpreter. We transpile to JavaScript. We already do this right now. Then eventually we want to go to the LLVM, but this is the last step. And before that, I'm going to transpile to C, probably. So no. LLVM is too much work at this point. I'm focusing on the high-level aspects of the language. for now. So I don't care about performance too much, even although I am making my LSP faster. That is what I'm trying to do, at least. But that's not because of, like, the compilation target. It's a different problem, or I'm doing the same things too many times. All right, so the issue here is that I don't see the actual stack trace. OCaml, OCaml, OCaml. Can OCaml give me the actual stack trace of the exception? Like, why is this like... Okay, when I re-raise exception in OCaml, do I lose original stack trace? Or how do I get it? You lose the original stack trace. OCaml treats raise exception as a new raise, so the backtrace now starts at the re-raise points. The correct way, we want to use a raise no trace. Oh, there is a different thing called raise no trace. So, like, in order to rethrow, when you do raise no trace, a faster version raise, we just not record the backtrace because it was already recorded previously, right? Okay, I didn't know that's a thing. The documentation is misleading though, a little bit. Well, now I have no trace actually. No, that's like, actually it's doing it. Yeah, we don't record the backtrace. Which is weird, right? I want to keep the original stack trace. Is that really that difficult? Let's log this with the error. This does bring the stack trace, right? We want to oh, we want like raise with the backtrace, get a raw backtrace. This guarantees the original trace survives. All right, let's try this too. This is how you erase an exception. Erase that string x subster ack in lib string xml. No. There's no way I don't have the exception here, right? Because the unhandled effect is not in a random place. Hello? Alright, anyway, like, I mean, I can guess where it is. It is happening when I'm initializing the expression, right? So the problem is in it over here, because this is where the inference is actually happening. So we have things like expect inferred as, right? Maybe I just Maybe I just do this over here. So expecting is actually this thing which is doing it with inference with... Wait, there is already inference with context? Oh, wait, there's already inference with context because I already do this kind of thing. Hold on a second. I already do this kind of thing. Why do I do this thing? Normalized bindings? What is this? I don't even know what this is. All right. Can I just say that, yeah, let's do like with context. It's just going to be also inference var with temp context. There we go. Function and this. Let's try compile. Is it going to work? Unhandled the thing again. Okay, but now no, it still is initializing. If only I had this stack trace, but OCaml does not want to give me like the one that is nice. We're having everything except the parts that are like important. Maybe if I... okay, what happens if I don't catch this exception? Then I don't erase it, and then I'm going to have the original backtrace properly, right? Right? Yeah, there you go. Like, how do I get to this line? Like, I mean, and over here I'm also erasing exceptions. So, like, how do I keep the original backtrace? That's my question. Why is this too much to ask of a language? You lied. I tried. It didn't. Get throw backtrace and return something useful while you're still inside the handler that caught the exception. Like this thing, right? I mean, I am inside of the exception handler, right? So why am I not having this same thing and I'm having something completely different? Compared to if I completely remove the exception handling here. You lied to me again. The backtrace is already overwritten with the with match. Entering the with handler itself performs an internal erase step. What? You are not reading the original erase side, you're reading the handler entry side. I mean, maybe it's because like I'm getting the backtrace here in the end instead of getting it in the beginning. Let's try doing it in the beginning. Maybe then it's going to be better. It is better. Oh my god, this is so annoying. It is better though. The actually correct way, use the exception pattern form with exception x, raise x. This form preserves the original backtrace when we raise the key difference is that exception does not perform the same backtrace resetting behavior as the generic with x. What? It's subtle, undocumenting, infuriating. Indeed. Bum, 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 bum. That's why people hate exceptions, because all languages do it wrong. I'm invested now? What do you mean? Oh, there, here. Pass your exact snippet if you want a forensic breakdown. I mean, yeah. Okay, this actually worked. But it's ugly AF. Yes. Higher order wrapper. If this is recurring, obstruct the whole thing. With the logged exception context, we try this and that. Right. No. Well, I mean, yeah, but so annoying. But okay. It's okay. It's okay. All right. We got somewhere here. So over here I do the same thing. I capture the backtrace first, and then we like raise with backtrace, exception backtrace, and then like now I'm going to have even a better stack trace unless I rethrow it somewhere else. Yeah, there we go. So now I actually see the line which performs the effect, which I previously did not see. So this is because we're trying to do... Oh, we're trying to just do type of value. So we're doing type of value shape. Oh, I mean, in this case, yeah. If I just want to know what is the current inferred value, I don't like, if I'm not doing the unification, that I don't need it, right? Yeah, in this case, I don't need it. Well, I mean, I can just say that we're doing it with context, I suppose. With temp context. All right. This is like unnecessary. This is kind of unnecessary. I don't know, like this whole thing is so fragile. I'm not going to be able to rely on this code, I don't think, while evaluating. All right, over here, let backtrace is get raw backtrace, trace with backtrace, exception backtrace. So now it's because I'm doing the substitutions. Because I'm trying to get this scope of the variable. Yeah, I guess in order to get this scope of the variable, it's the same, maybe. Await inferred is the other thing. Yeah, I think await inferred is actually I feel like I only need to do it during unification, like this over here and this over, like only the unite should use the context. Maybe that's how I do it instead. So with time context only needs during unification, right? Maybe. So not on every finding a root variable, so not the get current var. Maybe I need to do like the find root should see like should have the like use context. We have the use context variable here, so instead of saying with temp context, I'm just going to say that, like, for example, for the getting the inferred, we do not use the context, right? Find root var, use context, like this. So yeah, we just say that if use context, then this, else the var itself. Get current var from context. Setup default. It's context false. Print use context false. Actually depends like whether I should use it or not. I don't know. I feel like I'm doing it all wrong. This is all wrong, right? So when I'm doing the unite, find root, use context true, find root var, use context true. Set up default if needed. Use context false. Hello, Devninya. Hi. I am once again not making much progress. Considering a rewrite, but I should not. In which lang this time? Hacks? No, I think I would consider Scala. Scala sounds interesting. I have seen a lot of interesting things about Scala. Data. You're the first language designer I've ever met. Scala also has some sort of effect system with ZIO. Yeah. Scala have these like implicit thing. It's I think it's even closer. I mean, yeah. Like I'm not calling my effect system, I'm calling the context system. And I think Scala's thing is more close to that. Their implicit thing, basically. And I think their effect system is done using the implicits, I would assume. Where's the examples? Where's the examples? Homepage. Give me example already. Get started. The run method should return a ZIO value which has all its error handled, which in ZIO parlance is an exceptional ZIO value. One way to do this is invoke fold over a ZIO value to get the an exceptional ZIO value. Huh? What? It's monads? Yeah, that's what I was thinking. Like, this looks like the monadic stuff. So it's not the effectful stuff. Well, I mean, monads and effect systems are similar, I guess, but like, they are different also. Classical effect systems, Katz effect, ZIO, or Monix are based around the IO monad. To understand why we need effect systems, we need to understand the problem they solved, and to understand that problem, we need to understand what effects are. The effect of an expression is a concise summary of the observable side effects that the expression may have when it's evaluated. So the print is a side effect. Another example of an effect is a modifying state. Enter effect systems. The goal of effect systems is to bring the type checker and programming effective computations. These two kinds of effects can be represented by monads. However, in the Scala jargon, when we talk about the effect systems, we're talking about the former. Former what? The goal of effect systems is to bring the type checker when programming effectual computations. Former what? Am I supposed to read the whole thing? Classical effect systems are based around the I/O monad, since Scala already lets you write effectable code in direct style without using monads. What the I/O monads lets you do is suspending those effects in the I/O. The suspension means that effects are not executed immediately but are executed at a later time. Then this allows to separate the definition in the effectful code and the execution of said code. Hence, the benefit of effect systems is separation of concerns. Combining these two benefits, effect systems can provide extremely optimized runtimes with precise semantics. I mean, I understand. Are they talking about something different than the monadic approach that, like, these libraries are doing? Like the thing. Hello, NPC master. What's my hardware env? I have the Neo fetch, I guess. Fast fetch? Fast fetch better than the Neo fetch? I guess. It shows some more things, like the fact that I don't have the swap enabled. There we go. Imagine a potato, that's his hardware. Yeah. Yeah. It's pretty old, I guess. I'm too lazy to update my CPU, but it's fine. It's not a potato, Dev Ninja. Or wait, is like, are they talking about Cat's effect? Because Cat's effect is different. No, classical Cat's effect is Cat's effect. Yeah, this classical. It was final. Approach is modular. The future. As we have seen above, algebraic effects are qualitatively better than the monadic counterparts, as they are composable. Alright, I'm not going to read the whole thing, though. OBS is eating resources like crazy. It's like, it doesn't matter because I'm not writing code anyway, right, Dev Ninja? Alright, at least not anymore, you know? When I start this project, we were writing code really fast, and now I am like, I'm lost in my own spaghetti here. Compare. False. Equal. False. Recurse ID. For. False. 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 Alright, I am absolutely not sure if anything will work, even if I fix this error over here. Oh, exception already mutating. That's different one, right? So I'm already performing the unification, even although I have done the unification previously. Okay. Already mutating. Does it mean that, like, if I'm already mutating, what does it actually mean? I should use the existing context then? Is that what I should do? So I just call function f, else we do all of these other things. Let's try this. Something is going to happen, right? No, we still have an error. Okay, when I'm compiling this... Yeah, because we do inference var unite on the labels. Okay, inference var with temp context. Right. Sure. You expect this to happen multiple times? What exactly is going to happen multiple times? Me losing my mind trying to understand my own code? Yeah, this is why I'm considering the rewrite, but like, it's just going to end up in the same place, probably. Like, unless I change something architecturally. Completely, right? So like I said, like my inference algorithm right now is mutating the inference variables, and this leads to like to the problems, right? So should have just done it in the immutable way, but immutable way is like slow. So how do we have like the both things at once? Is the question. I should not worry about the speed right now, so I should have gone with the immutable way of doing things, right? It would be fast enough. Maybe. Alright, well, I'm compiling this native unwind token expression. So now it's because I'm substituting inference var unite. This and that. Yeah, sure. I'm dying of too much water. Wait, maybe like it should just be done automatically then. When I'm doing the unification, I'm just going to initialize the temp context. If I'm not in the context, right? So like, yeah, we are basically going to introduce the effect handler automatically, right? That's what I'm doing already. Is that a good, like, that? Then I don't need to change much code, you know? Like, yeah. So when you're doing the when you're performing the effect, you must have the effect handler present but this over here is basically a variable saying if I have it or not. Oh, but it not, no, that's not what I'm saying actually. This is different. I need to think of a different way, I think. Can we ignore this error? Is another option is to ignore this thing. Another option is to ignore this thing, right? So, like, is it actually that bad? That if the unification fails, let me commit these two things, which is just rethrowing the error properly. And this thing, re-raise exceptions, preserving backtrace. But this other thing, I'm going to stash staged. So let's see the old code. This still works. Like, maybe it wouldn't be that bad if right, so right now we compile this code, right? The x is int32, and then I assigning x to a variable which is int64. This results in x changing the type to int64, which is bad, but it actually happens in stages. Not sure why it actually says this right now. If I do this, then it works. If I do x in 64 without the let, yeah, the type is in 64. I think maybe it's in the inference base here with try. Is it this? If I have the error, then I return A. I'm discarding the continuation here, by the way, which is leaking memory. Yeah, yeah. So over here, what happens is that I'm saying that both of the variables are equal to variable A. Then the unite data actually fails because int32 is not in 64, and then I just return the variable, and they are already equal to each other. Yeah, that's what's happening here. But what do I do in this case? Like, do I... Like, I'm tempted to also just try to undo this thing to return these two things to their previous state. In case the error is happening. It's just that the previous state... Yeah, it's just like, it's just wrong, kind of. Some... So what do we want here? How do we want this to actually perform, right? So right now the X is in 64. So one of these just takes priority. Randomly, I suppose. Pretty much randomly. I think it's like literally RNG. Or is it not? No, it's not RNG because yeah, the RNG is here, but this thing is not yet. Yeah, it's whatever. Unite data. So if I don't do this though, if I don't if I don't change the states here, United data final. All right, how about this? How about this? Let old state A be root A state. Let old state B is root B state. And then if this fails, so we're just don't go into the try with this effect. Over here I'm returning root. Oh, I'm returning like the variable here. Yeah. Okay, so like this width goes here. I think. Because that is the thing that can break, actually. So now if it breaks, then we are going to return, we still need to return something here, right? So we return the first one. This is not too bad, but we must change the state back. So root a state is old state A. Root B state is old state B. This is probably very wrong. Alright, but this is the simple change. Also, if we have no errors in the code, then it still works perfectly fine, right? So we might just not be resetting the state properly here, is the only issue supposedly, right? So let's take a look here, right? If I restart the language server, okay. All right. Yeah. So see now we see the change. Now x is still int32 because it was an int32 before, and like the first thing that we infer about x is that it is an int32. So the order here is what matters, right? Then we later try to unify it with an int64 and it fails, but we don't actually do the unification, right? We revert the state back, and that is kind of working on this simple example. So yeah, the example that we would see before, a little more complicated, is that if we have function f, which is stdio print, right? So this is a function, string into unit. If I make this to be int into unit, then it says that like the type doesn't check and it is still string into unit. Even though, okay, there we go, right? So this is actually different than before, right? So the stdio print is now the function that is string into unit, and f is a function that is int into unit, because we have explicitly annotated this, but we have actually not unified the type, so they are different, right? It kind of works. This is hacky and probably will break sometimes, but maybe this is good enough. I don't know. We will probably like, I don't know. Maybe we will just. This is the tiniest like change too, right? Kind of tiny. We revert the state back to the old state instead of doing the immutable way. It's just that if someone else is changing the state and stuff, things maybe can break somehow. I don't know. Maybe it's fine. I don't know. We'll see. Maybe if something is buggy. If not, then not. All right. So let's pretend that this is done then. So now, if the errors are not changing the things, right? All right. Revert variable states in case of inference errors. There's another thing in my inference which I'm pretty sure is like very wrong, because if I'm unifying the errors with something, then I get this something. So this means that, like, how do I get the error though? The error type is a question. Maybe I don't even get it anymore. But this unification is probably wrong. When I unify the error with anything, then the error disappears and it becomes this thing. But maybe it's fine. We'll see. Right, so we just want to cache the results of the compilation now. Maybe. Let's try to do that. So in my LSP processing, we have this to do, make imports immutable. Let's just pretend that everything that is inferred properly. So now, like, now we are like in the case of the type checking errors, we are not going to change the types, and it should be fine then, right? Right? So I just do not clear the cache. Let's just try commenting this line. Is that all that I need to do? Is that all that I need to do? Let's try restart language server. So supposedly now if I type a character here, we can get like almost instant feedback. If I take a look at the output of the language server, so recalculating the LSP stuff now takes 0.3 seconds. That still seems like a very big time. This is still a big time, I think. For this little line, right? This is a single line. It should be like taking no time. It's like I'm still processing the standard library. That's a big improvement on 6 seconds. It's because I changed the no. It's not an improvement because I have disabled the checking of all of the examples. I only am checking a single file and standard library now. So what happens when I process the workspace, right? If I'm not clearing this cache. So we're just going over all of the workspace routes and we're processing the file. Sure, because this is just the import cache. So I'm still like going to process everything from scratch. And only the things that are imported are cached, right? So like it's just the standard library basically. It's supposed to be totally cached. Import cache. Am I changing the import cache also? So like I'm initializing the import cache when I'm initializing the workspace, right? And when I'm updating the file, I am removing the file from the cache. And that's all that I'm doing, right? So the standard library actually should not be recompiling from scratch. Does it actually take 0.2 seconds for me to like do this? Let's do some more timings then. So I want to process a file. Let's just do log info processing file. Restart language server. see the output, right? So right now, so I was processing the workspace KS, and the test KS. Oh, it doesn't say if the standard library is imported or not, actually. Yeah, because like I'm only processing this file. This file is the one that is importing the std. So maybe it's on the import. Where is the import defined? Calculate import. Is this the one? Import cache. Some imported. Let's try this over here. I'm just going to log imported from cache Yuri. And this is importing without cache. Right, so when I'm compiling this example, it is importing the standard library. If I'm doing this in the LSP, oh, so like look at this. It says importing from cache the stdlib. Okay, but I was importing it first when I'm processing the workspace KS because this file is just regular cast code actually. So it also is importing the standard library. And then the next time is just imported from cache, which makes sense. But now what happens if I do a change here? Then it is actually imported from cache. Hold on. Okay, so I am not importing this more than one time. So why does it take 0.3 seconds then? This is a lot, I think, no? 0.3 seconds is a lot for this file, which is basically empty, right? Let's say that I'm going to completely remove this file. 0.3 still, even although the file is empty, literally. Is it because of all the logging? Is the logging taking 0.3 seconds? Or is it I mean, okay, let's do this. Process in the LSP process file this. Timed let's wrap all of this and like calculating the time thingy so that I should know. Yeah, so look at this, right? So time for processing the cast workspace file is 0.3 seconds, this is when I'm just starting the language server, even though it involved importing the standard library. And then I was processing the test, and time for processing this was 0.11 seconds, so it's a total of 0.4. If I change the file, I am importing from cache the standard library. So the workspace KS now, instead of taking 0.3 seconds, takes 0.13. And this one is taking 0.14. And then next time 0.14. And then next time 0.16. And if I do little changes like this, I mean, yeah, 0, it's 14 still sometimes, yeah, maybe it's fine. What is like taking this time though? Like, I don't understand. If the file is empty, then what is there to do even? Like, there is nothing to do, right? Maybe it is, hold on. So there is this thing that's called interpreter natives. And this function init natives is done over here because I'm initializing the interpreter. And then initializing the interpreter is, and then this default thing. Yeah, because I'm evaluating this using this interpreter. Can it be that initializing an interpreter taking a while? Let's try this. Timed initialize interpreter. No, it takes 0.11 seconds. That's definitely not it. It should not be taking a while, yeah. What about the compiler though? Default. Let's do this over here, timed. So this is just for the LSP actually. Yeah, look at this. Initializing the compiler takes 0.12 seconds. Okay. Got it. And that's a long time, though, I believe, for initializing the compiler. And what's happening there? Not much. I mean, there is happening the prelude here, right? This is what's happening. We are having the standard library being imported, and then we use the prelude of the standard library implicitly every time, right? That's like the default compiler has the standard library available. So even though I'm importing it from the things, so which part would take the most time here? What if my parser is slow? My parser... Is my parser slow? Let's see here. State default. Oh, got it. Init import cache. In the university now, they have great programming classes with AI agents. They feed all the source codes into it and spit out the grade. Hold on. It's just like annoying. How do I timed sys time. Let's just return the float, right? So I just do this. Yeah. Let's do this. Let's do this. Let sys time. Okay. Log info. Time. Let's see. 1, 2, 3, 4, 5, 6. Let's try this. No, that's not right. I want to do sys time minus dot s in parentheses. I mean, this is importing the standard library for the first time, 0.3 seconds. That makes sense. But you are saying that let's do the language server restart. There you go, right? So it's this thing from 4 to 5. Even though I imported this thing from cache, it is still doing 0.11. Got it. So the slow thing is this compiler eval. Wait, compiler. Wait, what do you mean compiler eval? Why do I need to eval anything? Oh, yes, it's because like the prelude itself. Okay, I mean, I guess like I am compiling this little file every time. Is that taking 0.1? Or is it the importing? How about compile, where is the function import? Import. Like calculate import, is this the thing? But I mean, it is imported from cache, but the calculate import is used over here, right? And all of this maybe is doing a long time. Okay. Right, let's try this. Timed. Actual import. Actual import is taking this much time. Maybe like the actual import like after I calculated it, right? Like everything else. Right, like import after import. something. No, this is 0.36. But if it is imported from cache, wait, what is slow then? Is it parsing this thing that is slow? There's no way. Let's restart language server. Yeah, the actual import is 0.4. Yeah, this is like no time at all. Okay. Let's move to another suspect. Is it actually... Well, no, it's not parsing, right? But I guess it is compiled, because I do compiler eval the AST, which means I need to compile the AST first. Can I compile this prelude only once? I probably can. This is like a micro optimization, maybe like 0.1, but it's 0.1 like on every like on a bunch of things. So yeah, this prelude should probably be compiled just once. Right? Prelude. Compiler eval. Make compiler state. State is when it import for name part. All right, I mean, I see this issue. Maybe we can ignore this one too, though. Maybe we can ignore this one too. So it's supposedly actually faster than it was before, still, right? So once again, recalculating now takes 0.3 seconds. I should not have reverted it, but I mean, this is a simple change here, right? Timed. So that I actually have the idea of how long they are being processed. Right? Yeah, so I'm processing two files here. One is the file in which I specify all the files that need to be processed, and then the files themselves. And for every file, we need to initialize the compiler, which takes 0.1 second, or a little bit more than that. So 0.15 here, 0.13 here. So yeah, like 0.3 in total. A little more, a little less. So yeah, but here's the thing though, right? If this workspace file is not changed, do I need to re-evaluate this, right? So I'm trying to just see the result here. I do not, right? And also, I am still processing every one of these files, even if they did not change, right? So what I want is like, yeah, this like thing. Right, so when I process workspace, what I'm doing is I am processing workspace roots. Yeah, workspace roots. This is the thing. So workspace roots is reading the workspace KS file, and I'm compiling it here every time. Process file. Like maybe. Yeah, and like in this case, I'm also evaluating it. Maybe like it's fine if I evaluate it every time, but I don't want to compile it every time. Maybe what we need to do is like if we do process file, right? Like, or who is checking the import cache? I mean, it is not the import cache. That's the thing, right? Yeah, that's not the thing. We have the different kind of cache. Maybe let's call it just cache. How about this? So I'm not going to have the import cache. I'm just going to call it cache, and the state of the compiler just has the cache, not import cache. That makes sense, right? But it's not just the renaming. It's that, so these are the imports. Imports are either in progress or imported thing, which is value, which is basically the evaluated thing. Right? By Yuri. So the cache should have I'm evaluating the file. Let's call this imported, sure. But some of the files are not imported, they're only compiled. Imported files are evaluated too. So we have imported, and I will also have compiled, right? So we compile the things what, as expressions always? So just expression Yuri map T. Is that right? Found out about Tmax, it's so cool. Congratulations. Congratulations. There are alternatives to it. I don't use Tmax really, but so yeah, whatever. It's cool. Global state cache is compiler cache. Cache is global cache. Cache import cache. So yeah, I guess like this dependency thing, maybe I want to do like global cache. This is mutable, right? So I want to say global cache compiler cache remove cache. I guess like invalidate the URI. I guess is what I want. The root I've included, I guess, is also like, why is it the LSP that is doing this? So yeah, if I have changed the thing, then the compiler should know what to invalidate, right? I think so. Although the root I've included, yeah, the root I've included is the thing that should not actually be here. But I'm imagining that it should. Yeah, root I've included, yeah, whatever. We're adding the, yeah, if the file starts processing, we're adding the root I've included the thing, yeah, and then I'm removing the things. When am I actually using it though? Am I actually using it anywhere? Like only to invalidate the thing, and that is just going to be handled by the cache there directly. Okay. Yeah. So let's have this. Let's have module cache. T is cache. So I just do what? I say invalidate your T, URI cache is T, URI is URI. So this should remove the things from the cache. Cache imported. So the root URI, because like we can include the file from another file. The root is like the root of the compilation unit, basically, right? Which is the thing that is being imported or compiled. So we need to figure this out. And I guess I store this information in the information is the cache, right? Root URI map find opt URI option value default is URI. So we just do cache imported. Cache imported is what? It's also a URI map. So I need to mutate it, right? Cache imported a URI map, remove a root URI. There we go. So we do this to this one and to the compiled. We just need to figure out what is the root in the cache. Mutable root. Also, I'm going to remove it from the root. I guess this like doesn't really matter, but we might as well remove it from here. So I'm removing the URI itself. So root is just the URI to URI map. And now what happens is that when I am importing or including the things, yeah, when I'm including a thing, which is in the core syntax, I guess, include root over here, right? So when I'm doing the include, here's the URI. So the file started processing. I already have my cache here, right? So can I just say that C state cache root is C state cache root URI map add URI root. I can only include from the currently compiled file. So root is this. Okay. Right. Init cache. Okay, so this works. I mean, this compiles, and it probably works. It's not all, though, because I'm not populating the compiled cache. So how am I compiling things? Like in the LSP here, right? In the LSP, I'm invalidating this URI. And like also, I guess like the traversing the dependency graph and invalidating the other things is also going to happen here. To do dependents are going to be invalidated automatically there. So when I'm processing a file, I'm creating the compiler and like parsing and compiling this thing here. Like, why is this logic here even if it should not be here? Well, I mean, for this file, I do want to know not only the final expression, right? We literally want to know everything about the file state, right? Which is the URI, the parsed and compiled. Yes. Yes, which is both the kind and the thing. Okay, so it's not necessarily an expression where you can compile anything, like a pattern in a file too. It seems. So this is literally the thing. The file state, like this should not belong to the LSP even. Right? Yeah, and also the workspace file technically could be imported, I suppose. And then it would be cached automatically. So workspace state is this, files. But like, yeah, we don't even have this, and like we just have the cache. The compiler cache is having all of the state that we need. Right? So these are the files. So some of the files we're importing, some of the files we're compiling only. Yeah, but this is like, yeah, let's say this is compiled file or something, right? So this is the file state. Compiled file. I don't need the URI, right? I just need the parsed and compiled. Well, I mean, these things are optional. Why are these things optional? Can it be none? Option bind AST. Why is parsed? Yeah, we just return some result here, right? I guess I return none if there was a crash there. Yeah. All right. Yeah, I just need to move all of this logic from the LSP to the compiler itself. I mean, this is doing the diagnostics, I suppose. But the diagnostics... we should just be able to reproduce them from the cached state. I'm not caching the diagnostics right now. Right? And like if we compile the code, we don't want to recompile the code to get the errors back. Right? So the errors should be stored in the like when we do the cache in the file, we would store the errors there, right? Two. In a different format though that the LSP expects, so like in our own internal format. But yeah. Like I'm almost there. What I need to do is compiled file. Well, I mean, also, by the way, we are saying like this parsed and compiled thing. Help, how do I quit Vim? How do you quit Vim? You Alt F4. Or press the power button on the PC. That's another option. Potentially need to hold it for more than like 3 seconds or something. Term, enter, pkill, vim, enter. So here's how you can figure it out. If you're in Vim, you can try help quit. All right, and then it tells you the thing. You can like read all of this help, and it tells you how to quit. You just ask for help. Let's get familiar with the Vim. Nana feels weirder than Vim. What do you think about VS Code? Is VS Code weirder than Vim? Or I never used Nana, so I don't know really. Is Nana also having the weird like? Nano is not model, right? That's what I know. Oh, I have it installed. Welcome to Nana. For basic help, type Control G. Control K to delete copy. Copy current line. M6. Alt 6. Is M Alt? Have you used or played with Copilot plugin for VS Code on Vim? No. No, I don't use AI that much. I just talk to ChatGPT sometimes. Wait, how do I quit? How do I quit? Exit. Control X. Save modified buffer. No. Right, successfully quitted Nano. Nice. No, you think if I added the Copilot to to my project here, I would be able to make progress faster. I'm not sure. Can we just say like can AI just write cast for me? The tricky part is I cannot skip the designing the core philosophy. Why not? Are you stupid? The core philosophy isn't syntax. It's the reason someone chooses cast over literally any other language. Do you not know what people want from a programming language? Okay, can you just make the best language where we don't make compromises and have everything? All right, so we want something that's multi-paradigm, functional, object-oriented, imperative, reactive. We want a type system, optional static typing. Why is it optional? Union types, dependent types. Yeah, see, like it knows what we need. Garbage collected but with manual control. What? Concurrency. Syntax, ultra readable but powerful enough for macros meta programming. Basically asking to be the next C++. C++ is the only which fits all? No, C++ is not fitting all, for sure. C++ does not hit the safety mark at all. What's your current favorite language in development? Maybe you can give up cast and start contributing to them if they need help. No, that's not fun. We need to make cast work. Koka is okay, but I think that out of the languages, like the anti-language, potentially, they are looking for the contributors too, by the way, and they are written in Rust. But I'm not. I mean, I don't like. It's not the ideal language, though. You know, it has some nice things. All right, what are we doing right now? Unbound module parser. Hello. In file none, line 1. Excuse me? Oh, camel, oh, camel. What do they write Koka in? Like... I don't remember. GitHub. It's not self-hosted, right? Stack YAML. Wait, is it in Haskell? Oh, it's actually Haskell. The new C++ is more looking like Java to me. What if you forked Koka and used it as a base to implement cast features? Nah. Why? I'm not really struggling right now, right? It's just I have not worked on the thing in a while. Because I was playing the game, the Zomboid, instead of doing this. You think I should... So you are trying to convince me that I should drop my project and join someone else? Now. What if we do it the other way around? What if you drop your project and you come and work on Cast? You're willing to? But you're unable to understand the code? I mean, I cannot understand my own code either. So we're not... Like... We're in the same place. I am willing to improve the language, but I'm trying to hear it. That's just not that easy. We like rewriting it from scratch is an option. So that yeah. Like I don't want to rewrite though. How, like, okay. Like, what if we don't make the LSP faster, right? Like, is it actually important? I feel like this is the entire thing that I've been doing today. How important is it to, like, fix these things? Because, like, a lot of people, they actually work without LSP, right? I've seen a lot of people work on their projects without LSP in languages. In various different languages. Some even disable the syntax highlighting. Right? So, like, the language is kind of working, right? The language is kind of working. We use it to do a bunch of things already. So, like, what is more important? Is the language server more important than the faster compiled result? Right? If you can implement tree-sitter grammar for a stable version or default syntax, then you also have most of the semantics overhead. Well, I mean, we can have the language server that is only doing the parsing and not compiling, right? So that we have the syntax highlighting. Syntax highlighting is easy, I guess. One developer on our team alone wrote 20,000 plus lines over 300 plus files, a custom kernel L4 LB over eBPF, Inc. and Rust over legacy conc plugin in Lua. The whole team is strangled to understand it. I don't understand the words between kernel and Rust there. L4 LB over eBPF, Inc. What does this mean? The string of buzzwords meshed together. Layer 4 in the OCI model. Load balancer. Berkeley packet filter. So this is all about networking, and what does it have to do with the kernel? Or is this like part of the kernel? I guess like this stuff is part of the kernel. Are you working on the kernel? On a custom operating system or something? Can you check how much overhead semantic highlighting takes? Semantics highlighting. I mean, it's a lot, right? I guess, maybe. But does it matter if it is all just local? Well, I guess it uses more of the like CPU power and stuff. But I mean, semantic tokens, LSP. So like the reason why the Helix is not implementing the semantic token LSP feature is because it has too much overhead, right? That's what they said. I mean, I can just look into my implementation, I suppose. I suppose it is the LSP semantic tokens. Text document. It requires a lot of back and forth traffic with the LSP to do highlighting in real time. I'm not sure if that's true. Let's take a look at the protocol. Maybe the protocol is like not good enough. I mean, right now what I'm doing is that on every single change, I'm highlighting the entire file. Yes, this is too much, right? But I'm pretty sure that there is the way to like basically change the previous result, I think. Or maybe not, I'm not sure. If that's not part of the protocol, and then I guess, yes, this is too much, I suppose. Semantic tokens. So the request, the client will send a semantic tokens range request. A range, it can ask for a range. And delta, and there's also the delta here. So I'm thinking that right, there we go. We have the previous result ID, semantic tokens delta, right? Maybe this is like relatively new, like the delta stuff. Right, so like you can request the delta, which is like the difference between the previous result and the current version of the text document. And then it's supposed to be like less data passed around. So if you implement the LSP protocol properly, then it should not be a lot of data because only the delta is supposed to be sent, right? You can is who can, VS Code can, but does it? That is the question. I'm pretty sure that VS Code should do everything because like that's what's driving this spec, right? Isn't the LSP protocol originating in the VS Code? Like they're the main people who are working on it, right? So if something is in the spec, then it's probably in the VS Code, I think. Requesting a refresh of all semantic tokens. What does this even mean? Servers can use it to ask clients to refresh the editors. Oh wait, it's this server. The language server is asking the client. So like I can tell the VS Code to refresh the semantic tokens. So as a result, the client should ask the server to recompute the semantic tokens for these editors. This is useful if a server detects a project-wide configuration change which requires recalculation of the tokens. Makes sense, right? Like, it actually makes sense for cast, I guess, because if we can import the syntax from a different file, then changing a different file could potentially change the syntax highlighting in another file, right? Although this seems like it is refreshing the entire workspace, not just a single document, but whatever. Heard you rage quit zombie before, is that true? No. I just quit it. Without the rage. Nothing to rage about. Unbound module parser in file none. Alright, let's figure out this error in OCaml. File none. Which one of my files is none? What did I change? Bum, 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 bum. Game dev without engine is really hard. What exactly is hard? Can we have a better error message in OCaml? Like, why is it so bad? That's literally what I'm supposed to do. Look for parser in my code. Like, I didn't even change. Oh wait, I know what I did, right? It's because, okay, I think I know. It's because I was changing this thing, right? Parser result. There you go. This is it. But why cannot OCaml give me the good error message? But yeah, anyway, so like before I was distracted. So the basically the file the file the file any file that we process, right, is going to go through stages, I suppose, right? Which is we're going to parse, then we're going to compile, and then we're going to evaluate, right? So when I evaluate, I get this imported thing. So we have all of these different things. So I think I should have these in separate maps, maybe mutable. So we have like parse, parsed. So that's the result of the parser. And when I'm compiled, it's literally the compiled then thing. Let's do it in order. Parsed, compiled, imported. Well, actually, if I'm parsing the file, then it's just the URI and not the root. Yeah. So what do we want is cast let's see the LSP processing again, right? So when I'm processing a file, I should try to parse it. Parse the source. So I have this thing happening in multiple places, right? So the compiler is compiling the AST. And handle parser imports. Why don't you handle parser imports here? What is handle parser imports? Imported rule set. I don't remember this stuff. But my code is kind of duplicated a little bit. It's not like a big code. But yeah, so what's happening here when I'm processing a file, right? I'm creating the compiler, then I'm trying to parse this thing. And when I'm parsing this thing... Oh, yeah. So, like, when I'm parsing code, we have imports in the code, and imports are potentially importing the syntax, which is why we need the compiler while parsing. That's right. But why do I need it here when I'm compiling something? I don't know. probably doesn't really matter. It's handling something that's not going to happen then. In this case. Handle parser imports. Right, but I just want to have the this thing somewhere where yeah, so whenever I parse, the result should be put into cache, right? The result should be put into cache. Well, I mean, I can just put it into the cache manually here. I just don't think this logic should belong to the LSP specific code. But I guess we could do global cache. Parsed is global. And also, I'm parsing the other files anyway, right? Parse errors. Because I'm potentially going to parse not only this file, but the other files, right? But I guess I have a dedicated effect for it, where file included. Yes, we have file included, which contains the parsed and compiled. There you go. And then I'm storing the file state there. File included. And file imported. $65 stream streak? What? That's a lot. Addicted to cast. Yeah, if only I was like working on it a little bit faster here, right? When I am like just staring at my code for this long, and like I'm trying to do something simple supposedly, but I'm just like trying to understand what's written. This is where I start thinking about rewriting it actually. How many rewrites have we had so far? Just 3, right? It's not that much. Every next rewrite is better. Next rewrite you need to include comments. Yeah. No, I'm like I think that like we need to skip as much as possible actually. I just think that what I'm doing here should be done like easily, but it's not that easy it seems. But we should skip as much as possible and try to rewrite the language in itself, right? And then just do a better... Like, then I just need to improve the compiler a little bit so that it's not like super slow. I feel like these are the only two most important issues. The LSP, because I like having the LSP, and the speed of the compiled program. Was there something else? There's probably something else that I forget about. Like typed context system is not really that necessary, right? I mean, it's definitely not, because it's not... We don't have typed effects in OCaml, and we're doing something. Maybe the copy I think the copy move semantics is not done correctly right now. Yeah, that's probably one of the things. It has not been a blocker for any like of the code that I have been writing, I think. But yeah, the copies right now are the things that are supposed to be copies are actually copies by reference instead, which is wrong. Guess that is another issue that I would fix. Not sure how easy would that be. Cheating, yeah. I don't want the interpreter to be fast though. I need the compiled code to be fast. We don't want to interpret at all, I think. Well, I mean, we interpret at compile time, right? But that thing is not slow, I don't think. I mean, it is slow, but it doesn't like need to be faster, really. Interpreter faster is LSP faster. Well, I mean, it's faster compilation, but how much stuff do we actually interpret at compile time? That depends on the project, I suppose. Right? Right, so does this thing even work right now? What have I been doing? Test. Let's see. Yeah, it seems like it does work. Hello world. Print. Din, 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 din. Does this work? Oh, it does. I'm actually thinking that like the only workspace that has a lot of roots is this one, right? This is the only workspace that has a lot of roots. And when I'm going to actually work on the project, there's going to be only a single, like the main KS file when I work on a game. So I'm actually, and like even if I'm working on my like if I rewrite the language in itself, there's only one entry point. And what I'm trying to optimize here is so that I don't reprocess all of these example files. I feel like that's not necessary. Okay, I think we can skip it. I think we can, right? Because like otherwise I would always need to recompile this file, like on every change. Like if there is only a single entry point, then on every change I will need to recompile, because like this main file, whatever change I make in the code, that one will need to be recompiled anyway, right? So we only have the import cache and it's fine, because we only need to cache the things that are imported. Okay. I can just ignore the issue, I think. We don't want to yeah. This is so ideally we don't want for all processing though, right? Dependency graph. I feel like it's just the dependency graph that's needed. The inference completion, we need to look into that. There was something that was not inferred in my code, I think, for some reason. But the dependency graph would is important, right? So like properly clearing the cache there, properly invalidating the cache. I still probably want to do this. To do this change that I was doing. So the parsed, compiled, parsed and compiled are not used yet. To do parsed and compiled not used. This is basically just me importing import cache into cache then. Not really any important stuff. So just the dependency graph. I don't have the stuff to test it on here, because I basically have the standard library, which is a single compilation unit. Can I make the standard library not a single compilation unit, you think? how easy would that be? Here's the standard library that we have. So I'm just doing the inclusion here instead of importing, because like the range depends on the iterator. Like we would need to do this importing properly then, right? Like we need to import everything, including the integer and stuff. We could try though. Like, where does the int32 belong? Right now it's just in the root of the standard library. We can structure it better first. CMP. Also, like, we are implementing all the syntax in this file, and we want to use it inside. It's probably fine if the standard library is all a single thing. It doesn't matter. We don't touch it that much, do we? But when I'm working on the game, I definitely want the dependency graph there, right? So how do we do this? We when I import something from within another file, right? So I already have this effect called file imported. Hello, Epsilon. Yeah, not to be confused with the Kuvi boy. This is Kuvi mainstream. Welcome. I'm working on my programming language, and it's difficult, and it's hard. Today I was trying to look into making the LSP faster. I did some very small changes. It should help, but this one more thing where the dependencies... Yeah, I guess like let's do a simple example actually. Let's do a simple example. So we have this playground test, right? If I say over here, right, let's just say import foo.ks, right? So this is not going to work because this doesn't, it has no recursive imports, which is wrong, by the way. I'm not sure why this error is happening. What if I restart the language server? This just doesn't work. Failed to process workspace is error, no such file or directory. Oh, I'm not even like, yeah. I'm literally panicking when I cannot open a file. But this is fine. This is not happening very often. I'm not prioritizing fixing this error message. Just have foo.ks here, right? Let's say, I mean, I don't even need to say anything here. Let's just do this. Now it says no recursive imports. Restart. and it's fine, right? So there you go. So so this is just a unit because there is nothing written in this file, right? Let's say let x be import, right? So x is a unit here. Okay. So if I say over here 1, 2, 2, and then I look here, this is, oh wait, this is actually changed. Oh, but this is changed because I'm importing this from inside the test, right? So like this file is always recompiled, right? But if we have the transitive dependency now, let's say that foo is actually importing another file. It's importing goo, right? And goo is hello world, right? So then I just say import goo ks. There we go. So this is a string, because that's what we have in goo, and so x here is a string. We know that. But now if I change goo to be like this, for example, which makes it right, so everything is still a string. So why? Why? So what happens here is that this file is changed. It triggers reprocessing of the workspace. But since the foo ks was not changed, we are assuming that it did not change. So we don't even like, we don't even highlight, we don't even try to recompile this file at all. By the way, isn't this the wrong like way of doing things, like completely? So we have the file, we have the file test, and this file is importing foo, and this file is importing goo, right? We have this, and when I'm changing this file, when I'm changing goo, like what happens is that the language server is trying to recompile this file, and this is just wrong, right? We should actually try to recompile this only. I mean, not only, but like I mean, so the reason goo is being compiled is because it's being imported transitively through the test, is what I'm saying, right? Is that okay? I mean, that's probably okay, actually, because the imports are one of the first things in the file. I'm just thinking that it maybe like is not the optimal thing to do, because we basically need to parse this file again, right? And so like we have invalidated, we're supposed to invalidate foo and invalidate test, right? So we start compiling from the top. What I'm saying is that what if we actually compiled from the bottom somehow, because this is the file that I changed, so I probably care about the LSP support in this file before the LSP support in the test, because that's what I'm working on, right? But this is not the workspace root, so how do I like do that? Right? It's almost like the invalidation of these things, of this file. I don't know. I don't know really. Like it can potentially be changed to be included, for example, right? Like we're not necessarily need to compile this file always. So yeah, that's why we always start from the root, and if it is still reachable, then we compile it again. So it kind of makes sense to do it this way. But yeah, anyway, what we need to fix is that right now the foo is not invalidated at all. So when I'm changing the goo file, because we need to like see all of the files that were depending on this and invalidate them too, right? So if all of the cache that we have is the if all the cache that I have is the imported cache, because parse and compiler not used yet, right? Then I want to know the dependents, right? So let's have the mutable dependents of the file, right? So it's going to be just the URIs, then URI map t. I think just like this. Dependent is URI map empty. And I need to populate this somehow. But let's say that this is populated. In this case, when I am let's say module cache is state cache. Can I do that? Jerry Wilkerson, hello. Happy to see more LangDev on Twitch. Happy to see you here. Hello. Are you also making the language, or you're just interested in other people who are making languages? Do you stream? I'm also following everyone who I see working on a programming language. Oh, you're a creator of Jank. Oh, I see. I think I've seen your post about Jank. Janglang. Yeah, I've been on the website already before. I don't remember exactly though. So you have a Lisp, Clojure, general purpose, interactive, value oriented, native compilation and minimal runtime, strongly compatible with Clojure. It's hosted C++. You're transpiling to C++. Is that what it means? Clojure on LVM with C++ interrupt. Yeah. I never wrote much Clojure though, so I mean I know that Clojure is a Lisp. That's all that I know about it, basically. I like that your examples include OpenGL. That's what we like. I'm assuming you're making games. Are you making games with this? Compile say shader. So this is just interop with C++ or what? Seamlessly switch into inline. Oh, this is just inline C++. Interesting. World-class errors. What is this? A condition. So you have like a conditional thing which with multiple. It's like I guess it's just like if this, else if this, and then else. I guess, right. You just need to flatten it like this because it's a Lisp. Otherwise, the else if would always need to be nested. Function act ID movie. Is it dynamically typed? Is Clojure dynamically typed? Yeah. It's just the C++ interop is statically typed. Okay. Right. So you have good error messages. I like this. I should work on my error messages at some point. Probably after the rewrite. How long have you been working on your language? I'm trying to do something something different, I suppose. Like I mean, I don't understand much here, but it's basically like a Lisp, right? So the strengths of this language are mostly the strengths of Lisps, where code as data philosophy and the powerful macro system is the important aspect, right? 3 years for this iteration. How many iterations do you have before? Since the powerful microsystem and the code is data philosophy is like the thing here. I think my approach to this, I do have the same stuff, but I do not do code. I do not do a Lisp. So my language actually looks like a language, but we do have a macro system and other things which are kind of Lispy, I suppose. What would I show for this? Custom syntax, I guess. Maybe. This is not a very good example, I'm not sure, or maybe it is. Examples, custom syntax. So instead of being a Lisp, I allow the customization of the syntax, but after the parser has done its job, we are kind of working with a Lisp, basically. So over here, for example, I'm introducing the new syntax contract for once, which is like a loop, but it just assigns the variable to the what would normally be an iterator. So you can just define a syntax, and then like when the parser parses this, it gives you these like inner nodes as the syntax nodes, and in Lisp that would just be like so this is like your data, and then when I'm implementing the syntax, this is basically just a function that is returning this data back. Right, so we have this function which has the element, iterator, and body, which are all of the ASTs, and we get the AST back. And in this case, this function is just directly quoting. I think in the Lisps, the quote is using the same operator, the backtick, but the unquoting is like the comma or something. But we can construct the code also using the existing syntax in the, I don't know. And library dependencies can also introduce their own syntax. Yes, over here I'm importing the SQL, right? So SQL is would allow me to have the embedded SQL in the code, and in this, I mean, in this specific example, we don't introduce the semantics, only the syntax to the SQL, right? So I'm importing the SQL syntax, and I can write these things basically here. And currently this implementation just debug prints the AST itself. So if I try to run this example, I guess, cast examples, custom syntax. Well, I was in the middle of something, but if I do this, so this is what I store my AST is, right? So I have parsed this select star from my table, and this is just, I mean, it's not exactly a Lisp, because it's more like tables, I guess. It's like named thing and the fields there. But yeah, we basically have this stuff. Not a lot of languages do that, but I like this. I like the way it works. Like, and it's not just the macro system. We also have the statically typed language. So these macros can also have access to the type information. We have something similar to Zig, which is doing the comp time evaluation. And this over here is just a function. So like the macro system is just the function that is being evaluated at compile time, like after parsing. To expand the macro, we just evaluate the thing, right? And when I evaluate this, we have access to everything, and I don't know, it's just so nice. I have this example actually of the derive macro. So if you are familiar with Rust, for example, that would be something similar here. So the deriving is basically just a function from a type to the AST, right? So I just give the type as the argument to the function. It produces the code, and then we just include this code in the final result, I guess. Yeah, we just include the AST there. And then we just have some reflection stuff in the standard library, which allows us to do this type inspection. Kind of similar to Zig, I suppose, but in Zig you don't like produce the AST. It's a little bit different there. So yeah, something like this. This is something that I guess I'm most proud of in this language so far. There are other big features that I'm planning for. But yeah, it's a work in progress. I have not worked on my language for 3 years yet. It's only been how long? How long has it been? I think it's 1.5 years. But I'm also taking breaks for other things. The backend right now is JavaScript. So I have the interpreter because it's running the interpreter is required to do the compile time evaluation, right? So we have that, and the JavaScript because it's just the easiest compilation target, I think. But overall, my plan is something like this. I will eventually probably want to compile to LLVM for the maximum performance, but we're starting with the easy stuff. And there's going to be a C transpiler before I go for the LLVM, because I think that's also easier than doing LLVM. But I have no idea because I have not done these things before. This is my first programming language. But yeah, I have done some things with it. I have solved the advent of code and made a simple game with it. The next big thing would be just to like start self-hosting the language. So which is why I'm trying to work here on improving the LSP. I will need to improve the JavaScript transpiler because it's like it's transpiling, but it's not running fast because I'm transpiling to async JavaScript for certain reasons, and in order to get rid of the asyncness, I need to do more inference, I think. I should probably like also inline certain things to, if you git compile, you can get rid of the interpreter. No, allow for the same implementation. Yeah, but I don't know if like yeah, I mean, yeah, but I'm not sure about that. Like when you JIT, you need to, the comp time is like not very different from the runtime, but I guess it's supposed to have more features, right? So during the compile time, we can treat types as values, but during runtime, we don't. I mean, it depends also on the runtime, because right now in there's different ways to compile generics, and like there is the like sometimes you want to compile for maximum performance, and sometimes you want to have the fast iteration cycle, so you want to compile fast instead. So you instead of doing monomorphization, for example, you can do other approaches, right? Where you actually do store some type information at runtime, but I don't know. It's not that easy to just have the JIT, I think. But I was thinking about it, yeah. Not too much. Especially how Lisp macros work, with JIT compile the function and run them at comp time. Yeah, I guess. It's just all you need to do is basically to have the interrupt between this JIT thing and like the actual like language, I guess. I don't know. I have not done much JITting. I only read a small thing about it, so I didn't try. Maybe it would be easy. I don't know. None of it is easy. Okay. Okay. All right. Yeah. So like, I'm just trying to like go for the easy stuff, right? Obviously, the regular like the tree walking interpreter is what I have right now. That's obviously the easiest thing. So that's what we start with, and like the plan is something like this. So I don't see myself doing LLVM for a long time. I can see myself starting to transpile to C, maybe in a year or something. It depends. It depends on also how much time I spend on this. Yeah, there was also crane lift. I was also there's also QBE listed here. I heard that QBE is even easier than crane lift. If we want to go for the simplicity of the implementation, then QBE is easier than crane lift. I heard. But I think transpiling to C should not be difficult. Like, that is something that anyone could understand, right? Generate C perhaps unlike fill C is a good target for safety. Well, I mean, I was considering transpiling to Rust because of safety, but it's actually necessary? Because the language is supposed to have these safety checks already in it. Like the reason I'm transpiling to JavaScript, I could instead transpile to TypeScript, right? That's like kind of the same thing. I could transpile to TypeScript for a little bit more safety, but that's just more work too. I don't know how much more extra annotations there are in fill C. Fill C achieves complete memory safety with 0 escape hatches. Your C or C++ software most likely compiles and runs in fill C with 0 changes. Isn't this two things contradicting with each other? If field C achieves complete memory safety with zero escape hatches, then your existing C or C++ code should not compile in it, right? Because your existing code is probably not memory safe. Unless this memory safety is achieved at runtime, is what you mean. Oh, maybe it's just in runtime, right? So it's like you just compile C and then just adding the checks for you. Is that the case? It's not a zero cost memory safety, right? Okay. Yeah, maybe then it's then I do like this approach, yes. So that we don't have undefined behavior on miscompilation. We're going to actually see the runtime error. Yeah. Although I would probably just I could probably just generate this runtime check myself when transpiling to C. So well, I mean, having something with no undefined behavior is good, of course. All right. Just want to say hi. Yeah, no problem. I'm not making much progress anyway. I'm just staring at my code because I have not been working on it for, I mean, not too long, I guess. The last time I actually made progress was like a month ago, though, probably. So yeah, mostly just been talking anyway. Actually considering to end the stream because I'm a little tired. Let's go WebSockets. If I'm not making progress on like this stuff, actually, maybe we'll write some code in the language. Maybe, or maybe I actually go REST. That's another option. Where did you see the WebSockets, though? But I mean, yeah, we need WebSockets for potentially making a multiplayer game for a game jam. Do you think WebSockets are difficult? Yeah, I did want to add WebSockets. Do you have WebSockets in Node.js? I want this server of the WebSockets. Where's the Node.js library docs? API crypto. You have crypto. Oh, that's different crypto, right? I mean, yeah. Globals async. Is it networking? WebSocket. Is it in the net? Net server. Like, is net server a TCP or IPC server? That's too low level, right? We want WebSocket needs HTTP server. Or do you need libraries for that? Where's the search? Where's the search button? Is there no search button? Or am I blind? Alright, you know what? I'm not going to look into that. Where was I? I need to git stash pop. I need to change the compiler, right? I was trying to remember the dependency graph. That's what I was doing, right? So we have the cache. The cache has dependents, and dependency is this thing. And I want to add the dependency. So I only need the dependency for the things which are in the cache, right? Yeah. Which means that it is when I'm importing the thing. Or let's first do the invalidation. Let's first do the invalidate. So invalidate should also invalidate the dependents, right? Yeah. So dependence is I guess let's do match cache dependence Yuri find Yuri. So we find the dependence not of this Yuri, of the root Yuri actually. Well, I mean, do I need it though? Do I need the root? Do I need to know the root? Because it's just like when I include something, that's also the dependency, right? So we do it like this, and I don't do the root at all. Yeah, I think that makes sense. So I just remove the Yuri and all of the things. Match the dependence here. And if we don't have the dependence, then we don't do anything. If we have dependence, then the first thing that I do is that I'm going to remove the Yuri. So we don't do it twice. All right, and then after that, we say dependence. Oh, dependence is not a this. This should be a list, right? So it's a Yuri list map. So dependence list iterate dependent, and I mean, and for every dependent, we need to invalidate them too. That's all, right? So just say function dependent, we invalidate dependent in the cache. There we go. So this is easy, and then I don't need root, right? So over here, for example, I'm including the file like this, and all I need to do is to state that dependence, or let's say state cache add dependency. I guess we just do this, like add dependency on the not even on the root, right? I'm adding the dependency on the current file that is including this other file into the other file, and then we're going to traverse to the root automatically. Yeah. So I don't even care about the currently compiled file then, which is like the root. Okay. So I add the dependency. Parent is span Yuri, right? So this is my current one, and child is Yuri. There you go. Let's see. Let's add dependency. Child, like parent child cache is cache dependent cache dependence Yuri map update the, so it is the dependent. Should not call it parent and child, right? What do you call like this pair? Like it's not parent and child, right? The dependent and the dependee. What do you call them? What do you call each entities in the dependency pair? Head and governor boss. Like in dependency graph. Like in programming. I mean, just dependency and dependent, I guess, right? All right, there we go. So we just add the dependent to the head of the list, or initialize to an empty list. Yeah. Okay. Right, so the dependent is span Yuri and dependency is Yuri. Okay. That works. Compiler cache init. Compiler cache t. Compiler cache init. Compiler cache. What was here? Init. Okay, successfully compiled. But I'm not adding the dependency on the imports, only on the includes, right? So let's also have it on the import. Compiler, calculate import, Yuri, yeah. I'm importing Yuri. What am I importing it from? Oh, I have the span. So I have the span Yuri and this Yuri, and these are literally the dependencies. That's all that I need to do then. Right? I think we just do like C state cache, no state cache, add dependency. So dependent is span Yuri, and dependency is just the Yuri. Okay, is that it? Look at this, I'm actually being productive. I wrote some code. You think it works? Alright. The example still works. Let's try to go to this example. No, let's try to go to the test playground. So right now, this says that this is a string. I restart the language server. So now it's like a tuple with a string and only string. If I change this file goo and I remove these things, then it actually is a string. Okay, I think it works. First try, easy. Okay. How about we try this? How about we try this? So like there is still the language server is going to be slow on this specific repository because we have a lot of roots, because I'm recompiling all of the roots all the time. All right. Is it very slow though? Let's see. Is it faster than before? Hello. Oh, there you go. So recalculating LSP stuff took 10 seconds. But that's because the standard library was also there, right? Or is it going to take 10 seconds again on this other change? I mean, yeah, every single file is being processed for 0.4 seconds. Actually, that's a lot. The functor takes 1 second. That's a lot. 13 seconds for recalculating. Did I make it slower instead of making it faster? Anyway, let's try to go to this other let's go to the actual game example here, right? So let's have a feel of how it works right now. Right, like if so I'm going to comment this, I'm going to uncomment that. Let's see how long this takes. 1, 2, 3, 4, 5. I mean, it's going to say it. Cast language server. So 4.26 seconds, right? So this is using a bunch of I'm importing things here, so it should be much better. If I just change the flake here to say that cast is, how do you specify the path here again? Cast URL is file slash home treeman project cast lang cast, right? I think I can just do this. No. Is it path, not file? Nix flake path dependency. URL. I mean, it is the regular. syntax, right? We can have get HTTPS path like syntax. There we go. Place a corresponding to the local path can also be referred to by a direct path reference. Yeah. So yeah, I don't even need to say the path there. We just say literally slash. No. Why are you lying to me? Oh, a path URL. If the directory is part of a Git repository, the input will return just Git file. I've been doing this somewhere already, right? Where have I been doing this? Maybe in my Twitch bot. Yeah, there you go. Oh, I do git plus file, which is different apparently. Let's see here. Git plus file. All right, it's just going to compile it. I think this looks correct though. Okay. Properly invalidating dependent on file changes. All right. Okay, so here's the new thing. Let's see, it was 4.2 seconds previously, and now we say let x be 1, 2, 3. It was not instant, but it takes 0.6 seconds. So this is seven times faster, which is nice. But like, I feel like this should still not be this slow. I mean, there is 500 lines in this code. 500 lines is 0.6 seconds. 0.5 seconds. It's like 1,000 lines a second. Is that good compilation speed? Probably not, right? But better than before. This works. So if I change something, in one of these dependencies, let's go to the lib. So like these are also all importing, right? Let's go to gang. Let's say maybe that let's say that vertex also has the color, which is a vec4, for example, and see what happens after that. No problems are detected. Am I not reporting the errors properly? Or just build. Like we have the error here, right? And it's not reported in the LSP, which is weird. What if I restart language server? Oh, it's just now giving me the error and... Wait a second, what? Oh, I see what happens. So the error... This is the inference error. I should not be seeing this here. Right? But I am seeing this here. Why? I see the inference error. Instead of reporting it as a diagnostics. So what happens if I change this file? We're going to see this error again or not? Processing main, 0 seconds. Now we just cannot use because of this, because this is an error. Do, 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 do. When are you integrating LLVM to increase compile times by 3 billion% and make it blazingly fast? Soon, TM. Hello, Muscode. Which actually means not very soon. I don't want to be blazingly fast yet. I just want to be fast-ish. You know? Right now I'm slow. We do it step by step, you know? Alright. So why? You're seeing words like allocator, is that manual management? It's not exactly manual, like this is supposed to be let's see here. You're supposed to like, I mean, it's manual in the same way in which Rust is manual memory management. Like, do you consider Rust manual memory management language? I think I don't. Right? Because it frees the stuff for you. I don't know. What's the definition of manual memory management, actually? Now that I think about manual memory management. Manual instructions to identify and deallocate unused objects or garbage. Well, I mean, this definition in Wikipedia says it's just the instructions to identify and deallocate. It does not mean that it has to be unsafe, right? It's when you are calling those functions explicitly. But like when you identify the object, that's like when you just call a constructor, for example, in like, but calling a constructor I would not say that it's manual, right? And if your language is like having the implicitly inserted drop instructions, then you're not doing those explicitly either. So is it manual management then? So like I would say that the way it's done in Rust is it's also automatic. It's also kind of like automatic reference counting just at compile time. So the actual reference counting is not happening at runtime. Can you cause type confusion, use after free, double free, etc.? I mean, this is just the idea. Right now, I don't have the this implemented, but the idea is that you should be able to customize the allocator and in the form of the contexts. So you, when you say, Ross says right, yeah, I know. So we want Rai too, I guess. Although sometimes we also want to have linear types where you want that free operation to be explicit. Right now, everything is garbage collected. No. We're talking about the future of this language, okay? Right now, I mean, it's not like even garbage collected. Right now, like, I only have the interpreter and the JavaScript backend. Like, there is no way for me to do the stack allocation. Even if I wanted. Right? But you're supposed to be able to do that. So, like, yeah, I'm depending on the OCaml GC or the JavaScript GC right now, yeah, because I'm going the easy route for now, but eventually I will have Rai, similar to Rust, all of those things is the idea. But basically the allocator, like the way you work with the allocator is that, like in a language like Zig, when you say that you create new like new vec or whatever, right? In a language like Zig, you would take the allocator as argument, and like the size is like int, let's say this would return you the vec of these. Has Zig taken off yet? I mean, yeah, I think Zig is being talked about for sure. But yeah, in a language like what? No, it hasn't, and I hope it never does. I mean, I guess it depends on the definition of taking off. You hate Zig? Why do you hate Zig? What's wrong with Zig? I mean, I don't want to use Zig. But, I mean, as an alternative to C, which is another language that I don't know why I would use, but there are people who use C. If I'm given two languages, C and Zig, I would definitely choose Zig, I think. Would you not? Zig is poo-poo. I mean, if I am given the choice Zig or Rust, though, I would choose Rust, right? But you say there is no reason to use it, but is there a reason to use C? Is there a reason to use C? C is better than Zig? Is C better than Zig? I don't know. I mean, I have not done a lot of Zig, but why would I use C instead of Zig? The only reason to use C is to support niche platforms. Well, yeah, I guess. Summer and better link. This C is not a language article. Wait, I think I've seen that. C is not a language. Oh, by someone you meant I am going to link it? Wait, so in the summary, this says C bad? Where is the TLDR here? There are still even some features like flexible array that C Zig does not have. What's a flexible array? I mean, I guess I don't know C. Maybe if I knew C, I would actually use C. What's a flexible array? Flexible array fields? Zero length array fields. It's called flexible array and it's indicated by omitting the length like this. The flexible array has to be the last field in the structure and there must be other fields before it. Interesting. So it's like the slice in Rust, basically. The unsized type, which can be at the end of the structure. Yeah, I know Rust has this too, yeah. See, Rust better than Zig confirmed. Does it only work on the stack? Well, I mean, it's stored inside of the struct, right? Directly. Please stop giving me more tangents. We need to know if he's making a memory safe or memory unsafe language. I'm trying to make a memory safe language. Yes, I want to have the Rust borrow checker implemented at some point. Yes, right now, if you look at some of the code that I have, then you can already see that it's a little bit rusty. Let's take a look at the rip here, for example, right? Like, I don't know. You iterate mutably by doing the mut, the @mut thing. We have like this pattern matching with the ref mut, like in Rust and stuff. It's supposed to have the similar semantics to Rust. I just don't have the borrow checker yet. There are things though that I want to like I supposedly improve compared to Rust. There is this thing called Ghost Cell, if you know about it or not. It's supposed to be like separating permissions from data in Rust, which is like instead of having the reference, so like just having the reference to something in Rust already like has certain like guarantees. Ghost Cell is a dead. Does Rust put the length of the whole struct into the fat pointer, or just the length of the last field? I actually don't know about this. No, I don't know. I don't know. That's a good question. But yeah, you have like the ghost cell, which basically splits your reference in Rust into two things, which is the pointer and the permission to access the pointer. And then you can pass the permission separately from the pointer, which means that you can have multiple references to the same thing, which you can still access mutably, for example, right? And it's like more flexible and stuff. In this specific paper, if you try to like just use this as is in Rust, it's going to be not very ergonomic because of things, right? But if we make this a first, like the actual language feature, then I believe it can be good and allow code that Rust does not allow. For example, you can have the code like this. You can have let nut x is 0, and then you say like that you have function f, which is doing x plus equal 1, and then you're doing, I mean, you do the counter, which can be increased and decreased, right? Increase, decrease. This doesn't work in Rust. But what's actually wrong about this code? Like, if you do this in C, I guess this is safe, right? So the idea is that, like, this function is only capturing the point, like, it's basically going to have the implicit zero-sized argument, which is the permission to modify the pointer. So that this code is supposed to compile, basically. That's the short version of it. But I have not like gotten to that part, and I will probably not for a while, so yeah. Dynamically sized types in Rust. Boom, 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 boom. Pointers to slices and str, and also store the number of elements. Pointers to trait objects also store a pointer to a vtable, yes. And then if you have the DST, that makes the struct itself a DST, but what do we store then as the second thing? I would guess like that the thing that is stored for the DST as the last field is like this extra argument, so it probably would be the number of elements. Right? Okay, hold on. Did I break my language server though? If I restart it here. Oh, if I restart, yeah, I mean, I made a bug. Wait, hold on. So this thing did not compile, but it's supposed to still be as a dependency. So if I fix the compilation, the miscompilation, is it going to work? No, because it says no recursive imports. Okay, why do I have the no recursive imports? That's the question. The problem is you cannot actually construct a DST in safe code because constructing anything Rust requires putting it on the stack first, and you cannot have a dynamically sized thing on the stack. Are you sure? I mean, I have not really done much of that, but oops. Hold on, can I not have struct foo, and then we have like let's have like i32 and this slice of i32s. Expected i32 found i32 4. Yeah, I suppose. It's just because it's thinking it's the wrong type. Transmute, but transmuting is unsafe. I mean, wasn't there like a safe transmute or something coming to stable? Is this the transmute copy? No, this is unsafe too. Boom, 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 boom. I believe you can't even put it in a box. No, I'm pretty sure it works for a box, right? I mean, not full. But you can put the slice into a box, right? Well, I mean, yeah, this is also one of the kind of issues in Rust, which I thought I could fix, but I have not thought too much about the things yet. But like the placement, like initializing the things in place is something that we want. Oh, this cannot be known at compile time? Yeah. Because you actually still... Because the argument to the box new still need to be known. I thought the box new was like special cased, but I guess it's only special cased when it's compiled, and like for the purposes of the type checking, it still is acting as the normal one, right? Boom, 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 boom. Yeah. Box has a special in-place construction optimization. Yeah. Yeah. I heard about this, but it's not like I said. It's like this. Yeah, whatever. Yeah. Anyway, one of the few Rust function smart pointers. Well, I mean, isn't every smart pointer in Rust can do this? All the references can be DSTs. All the smart pointers that are in the Rust standard library, I guess, right? Not the third-party ones. Well, I mean, you can make the third-party one contain the DST inside. It just I don't remember. There is something. The colors unsized or some trait. Yeah. There you go. The colors unsized. I mean, it's possible, just in the nightly, right? Anyway. Nightly doesn't exist. There was a time where I was using only nightly, like back in the day, where like the first thing that I ever did in Rust, I was targeting the browser. That's what, like, my first project in Rust was targeting the browser. I was making these games for like forever in Rust for game jams, right? And I was always wanting to target the browser. And back in the day, you could only do it with mscripting, ASM.js, and it was only working on the unstable. It was a long time ago. Before WebAssembly was even in the browsers. Those were nice times. But yeah, I don't really use unstable anymore. There's a bunch of cool features there, though. Right? Like specialization, for example. Field projections. You cannot just look it up, right? Can you? Anyway, today I learned that find pointer stuff is not necessarily in pointing metadata. Okay, hold on. I'm going to do something here. So, okay, it's because I fixed the thing, which is why it's all working. So if over here we say dot foo is string, right? Then what's going to happen? So now we have unexpected punctuation here. Well, that's wrong. And now we have compiler error, no recursive imports. Okay, so what's the issue with no recursive imports? Because it, oh, okay, hold on. So no recursive import happens because no recursive imports happens because the import is in progress, which means that the thing over here in this cache was not imported properly, right? Yeah, which means that we just, yeah, I need to say that we need to do function protect. Finally is going to be I will love the day when I can write VA where V is a raw pointer. Wait, what? With the arrow, like in C, you want Rust to turn into C? Why do you need the arrow? Or is it like the arrow something specific? Rust unstable book. Or is anything about the projection here? Maybe it's not in the book. All right, so but yeah, if the importing fails, then I need to say that it's not in progress anymore. So do I just remove it? Yeah, because it is not imported, right? Yeah, it's not imported. Function protect. Works makes you dislike programming. Have you tried not working? You gotta build more weird stuff in your free time. Not working is not an option. I don't know. Not working forever is probably not an option, right? But I mean, like you probably already don't work 24/7, right? Like you have some time to sleep and do other things. So there's already some time where you not work. You can try increasing that time. Bam, bam. Professional YAML developer. All right, so what do I do here? I just do try. With. Let's do the finally. Whatever. Function product. Finally, after I did this, I mean, yeah, over here. Cache imported URI map, remove URI cache imported. All right, and I do it until over here. And this is the imported here, right? Nope, over here. Say let imported be this. In worst GitHub actions. All right, so is this it? Let's try reloading. Let's just wait for Nix to do the next thing. Okay. Cast language server. All right, so I have this thing, inference error. Like, I don't like seeing this in my log at all. Time for processing is 2.8 seconds. So it has been processed, but it has not been okay, so wait, what? So yeah, because I cannot import this, I cannot parse, because in order to parse properly, right now I require the imports to work, right? So it's probably fine. I don't see any problems though in this LSP here. So let's see again if I fix this. Okay, we see the highlighting and everything. This works. And if I bring this back, then I want to see the vertex is type. So I still do not see the error. Recalculating LSP stuff was quick. Can I do over here let x gang vertex 1, 2, 3. It does see the foo string. Okay. So it was updated properly, actually. Right? So I can say position is 1, 2. UV is 0, 0. Foo is high. Alright, so this works. Okay, but why do I not see the error message over here? This is just underscore underscore. So this is a list of vertices. So when I'm pushing this, data is a list of vertices, but this is not a vertex. Well, that's because it could not be unified. That's right. But inference error. Oh wait, is it because the inference error is just being logged and then I just like silently ignore it? I'm not silently ignoring it though, right? Inference error is happening over here. This is when I'm printing the error. So this is done. Let me see. It is in the inference base over here. Yeah, there you go. Look at this. It's because I'm having the error and I'm ignoring. Oh wait, no, I'm not ignoring it. No, I'm performing it again. No, never mind. Never mind. So can I have a simpler example than this? Right, so we just say that a foo is a type with A, B, and C, right? So I wanted to create a list. Do we have list? Yeah. List push list. No, yes. No, field push is not there, yeah. Push back, it's called. Yeah. Okay, this is a thing where I don't see the error message for some reason. Okay. Is it because it's... Why? Why is that? At the same time, if I say that foo is foo, and then over here I just say, let's get rid of... Wait, no error message because there was no error to show actually, right? If I just say A and B and forgetting the C, all right, there we go. Then I still don't see the error message, and now this is underscore unknown type. So yeah, list is this is the list of this thing. Interesting. If I say C is 3. Wait. Oh, it's like it still is not unified at all. Oh, I have a problem in my inference. This is not unified with this type at all. Oh, I mean, that's right, because it's supposed to be a list of foods, right? If I do this, that makes sense, actually. Okay, so now if I remove this, okay, I think this reproduces it still, right? So now I have explicitly stated that this is a list of foods, and there is no C here, and it's not showing me the error. Oh, the error is in this file because I'm doing the pipe here. Oh, yes. So like I have the macros, and the error reporting in the presence of macros is really bad. I did not fix that still, right? Yeah, so if I do the list pushback not list and this, then we're going to see the error. Where, like, yeah, the error is bad, but it is present here, is the important part. Okay. All right, you know what? I'm going to end the stream. It's been too long. I need to go rest. Maybe I have done some progress, maybe not. Who knows? We'll start making more progress. Soon, trust. So we have a game jam coming up in a week, the D2 jam. And I'm planning to use Cast to make language for it, to make a game for it. March 6th. It's going to last for 3 days. So, yeah. Hopefully I can figure out the couple issues to make the LSP not too bad, not too slow. But even if it is, I should be able to make at least a simple game there.
Good, and now we get rid of those.
Why is Cake streaming for 12 hours?
We'll put the banner in.
Anyway, thank you guys for watching. See you next time. Bye.